Hey guys, my name's Jackson and welcome to the Blueprint Fundamentals tutorial course. This is going to be a free course on YouTube where I'm going to go through basically everything I know about how blueprints work, so the theory and sort of how to think about the blueprints that you want to make, and we're going to do a bunch of examples where I show you as many concepts as possible to give you a full sort of comprehensive foundational knowledge of blueprints so that you can feel confident to go away after you've completed this course and have a reasonable idea of like, well, okay, if you want to make this sort of system in the game, how you'd go about doing that technically and with your blueprints. So my intention is that this will be maybe 20 hours long. It might be longer, it might be less, I'm not exactly sure. I've got a vague plan in my head of all the things that we're going to cover, but no doubt plans will change as we go along and more will come up, and I might cut some things out or whatever. So I'm not sure how long it's going to be, but by the end, I want you to feel sort of like you've taken an undergraduate course in basically Unreal Engine blueprints, so that you feel not necessarily like an expert, but you feel competent and like comfortable making the things that you feel like you want to make. So that's the introduction. Maybe I'll just tell you a little bit about me. So I used to be a chemist. I went to university to study a Bachelor of Science in Chemistry. I quit that career basically not long after, and found my passion for game development and started out making indie games just for fun because I fell in love with it right from the beginning, and started a YouTube channel, and here we are like 7 years later, and I consider it's my passion in life. It's my vocation in life, is making games and teaching people how to make games. So that's what we're going to do today. Before you start, there will be a couple of links that I'm going to invite you to check out in the description if you want more personalized help. I offer one-on-one calls with people where I can tutor you and mentor you. We can talk about blueprint specifics, or I can talk to you about your indie game, or just whatever you want, really, just one-on-one mentoring. And I've also got a course which is called the Indie Dev Intensive. So what we're going to be covering in the Blueprint Fundamentals is the technical understanding of how to work with blueprints. And then in the Indie Dev Intensive, that's a 12-week program where instead of covering the technical stuff in the engine, we cover more project management type stuff so that you can actually stay on track, plan your game, actually translate your vision into blueprints, without it becoming overwhelming, without you getting bored with it and losing motivation, and then actually seeing it through to the end and making sure that your project is organized, and sort of meta stuff that isn't necessarily down in the weeds of game development, but is absolutely essential if you want to actually survive in indie game development and make it to the end and not end up adding to the graveyard of abandoned projects like 99% of indie games, because it's so extremely difficult. So there'll be a link to those in the description, so please check those out, and there's some other links in there for other resources. But without further ado, let's crack into the blueprints. This is the Blueprint Fundamentals tutorial course, and today we're going to be talking about events. Let's fucking go. Alright, so to kick things off, we're just going to start by creating a project. So I'm just in the Epic Games launcher here, and if you go over to the library tab and then just launch a version of Unreal after you've installed it, I'm going to work in 5.6. That's the latest version at the moment. But the things that I do today, I'm going to focus on foundational sort of concepts of game design. So most of what we do, you'll be able to apply to earlier engine versions, although the nodes might be a tiny bit different, but it'll definitely be future-proof for later versions of the engine. The tech will improve and they'll introduce new stuff and polish things and whatever, but everything that we're going to be doing in this course is sort of foundational game design and development logic that is I don't think it's ever going to change. So, as long as you know how to think about game design and game development, I think that's the important thing that matters, and then the tools can improve and come and go and whatever. So we're just going to create, you want to go to games just here. There's a bunch of different templates that we can use. We're just going to roll with the third person one. It doesn't really matter too much. And just to start, in 5.6 now, they've got variants down here. So there's different types where they come with pre-built stuff inside the character. We're not going to use any of those. We're just going to use the no variant, just like that. And we're going to call this BP underscore blueprint. No, what was it? Blueprint underscore fundamentals is what we're going to call it for Blueprint Fundamentals, because if I actually type Blueprint Fundamentals, the name is too long and it doesn't let me create it. I tried to do that just before. So this is the project that we're going to be doing our work in. And basically what we're going to do today is I'm going to talk to you a bit about the foundational sort of abstract stuff about how blueprints work. And then after that, we're going to get into some specific examples. But the purpose of doing the abstract stuff first is basically to give you a foundational understanding of what it is that we're actually doing, so that then you can go and apply your knowledge to different situations and different examples that aren't necessarily covered in this tutorial. So let's go ahead and do that now. Alright, so let's talk a little bit about how blueprints actually work in Unreal Engine. Basically, the workflow behind all of game design and every single thing that occurs in the game sort of works like this. Is my pen actually going to work? Sorry, just give me a sec. This is my first time using tech like this, so it's a little bit fumbly. Number one, everything starts with what we call an event, and you may have seen these in the engine. They're the red little nodes. So examples of an event are things like begin play, overlap, event tick, etc. We're going to go through a bunch of them in a minute. But basically everything starts with an event. The second thing that happens is we get what I just call, oh god, I'm not used to writing with my hands, so it's funny that we have keyboards today, so handwriting is sort of just like gone out the window, and mine has just like deteriorated so bad over the years. We start with an event, so that's an event, something that happens in the world which we want to then trigger an execution chain of things to happen. The next thing that we want to do is after the event is we need to get what's called a reference to something in the game that's going to be affected, because nothing in the game can happen unless we identify something for that thing to happen to. And now saying that out loud, that's probably the basis of object-oriented language. It's like you have an object which is then affected by whatever the hell you're going to do to it. So event and then reference. And then the third thing, which you might have already guessed, is then we're going to have an action. So we've already got the object, which is the reference, then we want to do something to it. So some examples of things might be you want to destroy it. You want to do some damage to it. You want to change a variable inside it. Maybe you want to, I don't know, you might want to spawn something at that location or like etc. But basically you want to do something. And then because this is game design as well, if we just operate with those three principles, everything is sort of just occurring behind the screen on the computer. But because it's a game, you've obviously got a visual, tactile and audio element. And so you want to indicate to the player that something has actually happened. And then so number 4 is we have the whole concept of feedback. Feedback meaning the game is responding to the things that you're doing it in a way that makes it immersive. So things like spawning sounds, spawning sound effects, particles and just shit like that. And then basically I'm just going to add a 5th point here as well. But by the way, feedback is sort of like that's sort of the essence of what makes sort of what makes a good game. It's like you do your systems and things, interesting systems in the first 3 points. It's like how does they're the rules. It's like how does the world actually behave, and it's like if you poke it here, what's it going to do, kind of thing. All that sort of interesting systemic stuff is in the first 3 points, and then sort of the juice of game design is in the 4th point. It's like if you've got a game that's really impactful and has great visuals and graphics and effects and sound and everything, that sort of all falls under feedback. Whereas the actual game design itself, I think, sort of occurs in the first 3 points, and then also in the 5th point, which is what should I call this? I want to call it like cascading events, or maybe like chaining or something, or like continuation, or maybe we could even just put more events. Basically after you do all of those other things, it's like, well, then what happens? Do you want to end the execution chain, or do you want to continue to then have more knock-on effects to influence other things inside the game? And so believe it or not, everything that basically occurs inside a video game is just a glorified version of this. It's just you know, fleshed out into different mechanics, different systems, and different feedback and forms like that. So if you want to express that graphically and how that sort of looks in the actual editor inside of Unreal Engine Blueprints, is everything starts with our event, which is the red nodes, and I can't draw in white, but I'm going to do my execution chain in black. Oh, we just had that sort of glitch out. What the fuck just happened there? Who the fuck knows? Basically from that event, things execute from left to right, so we're going to drag that across like this. This is the execution chain, and then say we want to get a reference to something. That's the second step. So say in this case, if we got a begin play event in red, we get a reference to the self down here, and then say we want to run a node which is like, say, launch character or something, and basically the launch character node needs a character as an input. So the inputs, they go in these little pins that sort of sit down the node like that, and then the execution chains plug in above those. So every single node in Unreal Engine works like that. It's like you've got a place to plug in the input, basically, and then you've got a bunch of different pins down below that are color-coded, which tell that bigger node, this one here, how it ought to function. The one on the top is usually the target. So like I was saying before, this is an object-oriented language, so basically meaning that all of these nodes need something that they're sort of acting on, or a place where they can act. And so like if this is a launch character node, for example, it's going to take an input of a character, which can be here, and then it's going to take in a bunch of different shit down here, like launch velocity, maybe there are some other booleans which show up in red, etc. I'm sort of drawing off the bottom of the node right now, and I'm making an absolute mess here, but hopefully you get the point. And so that's the reference, and it's also the action. So this I'm going to draw this in yellow now. I'm just doing a little kindergarten hodgepodge of just crazy different colors and shit. That's the action, and then basically after that, maybe you want to have some different effects. So after that, you might spawn a sound, spawn some particle effects or whatever, and then the next thing is obviously, well, not obviously, but if you wanted to add more, then after that final thing there, you could go ahead and you could add more events. So you could execute another custom event, which then fires down here, and then maybe after the character has been launched back up here, the next cascading chain of events is, well, now an AI becomes aware that the character is just launched, and then like goes and chases them or something. And that's where you sort of get into systemic game design, where it's like you've got one chain of events that happens, executes a bunch of things all at once immediately in the chain, and then it can cascade and cause more effects to unfold. And that's how you get good, interesting, systemic game design. So I hope that wasn't too much of a head fuck, but I thought it would be worthwhile to go through those sort of basics now to add a little bit of context to what we're going to be doing next, which is diving into some examples. So maybe the first thing that we'll do is let's just right click in here. I'm just hitting Control Space to open that content browser at the bottom, right clicking to create a new folder, and I'm just going to call this Blueprint Fundamentals down here, and we're going to crack into some examples. So the first thing that I'm going to do is right click, and then this is where you can create all the different assets inside of Unreal Engine. We're going to be doing most of our shit in Blueprint classes, and so if you click that and you open up this prompt here, you hit the little drop down, you got all different types of blueprints that we can use, but the sort of core ones are up here, and we're going to go through how each of these work. But I mean, you can already read them on the side, but I find that all these descriptions, they can be a little bit abstract and you're not really sure like what the use cases are. So as we go through the examples and I show you how to use all of these, hopefully it'll give you a bit of an understanding as to their proper place and when you want to use them and whatever. But it's also worth mentioning at this point that there's not necessarily a right or wrong way to do your game. I think it's very easy to get caught up in like just paralysis by analysis and self-doubt and worrying about whether or not you're doing it right and if it's going to scale properly or whatever, or if it's going to perform poorly, and all those things. Like they're valid to consider, but like if they're sort of stopping you from just like cracking on and just making something that works, even though it might not be ideal, it's like it can be sort of counterproductive. And you know, your game doesn't have to be perfect in order to be fun and playable and, you know, like a work of art. So I just want to caveat that. But anyway, we're going to go ahead and create an actor class. So I'm just going to call this BP. Let's just call it events, and I'm just going to show you a bunch of different events that occur inside of this. So inside of the actor, we've got the viewport, the construction script, and the event graph. Most of our work is going to be inside the event graph. And as the name suggests, this is where we do all of our work with our different types of events. We can do some stuff in the construction script. I'll get to that later. And then obviously you've got the visual element of it here, which if we refer to our previous diagram that we did on the drawing, this is where, you know, all the visual stuff happens. Like maybe you want to change the way that your actor looks after a certain event occurs, but everything starts with an event. And so, yeah, let's crack into the different types of events. So already we've got begin play. Obviously makes sense. Happens when the game begins. You've got actor begin overlap. So when this actor overlaps something, this is going to fire. We've got event tick, which occurs every frame. And so just to spice things up, these three are sort of your bread and butter, but then you've also got plenty of other events that you can get access to, and which you'll sort of learn about as you explore in the engine and find out that there's something that the engine should be able to do that you might need, and then you go and find out that there's like an event for it. So event end play, that's when the game ends, or when the actor is being deleted or removed from the level. So you can get it to run some logic there. For example, one way that I use this is with save games, is when before you close down the game is you want to save the game, obviously, and then you can quit it. There's event on destroyed, or event destroyed. If we just type in event, let's see what we've got. End play, destroyed, begin play, a bunch of other shit for inputs. When the actor takes damage, event hit. I wonder if that's going to work. Yeah, like there's a bunch of different shit that you can use in here. And also, you can also add your own custom events. So if I type in my custom event, very creative original name, you can create your own stuff in there and then run your own logic off that. But then these aren't called by things that happen in the game itself. They're called by you adding them to the execution chain. So I can say my custom event up here, and so when the game begins, we might do a bunch of logic in here, and then this is where you sort of add that, the fifth step that we talked about in that little diagram, is how you can have cascading events where, you know, that can lead to this, which can lead to this, which can lead to this, etc, etc, etc. And so like this is step one. This is how you can start. Now before we get into these, I just want to show you with the actor begin overlap, is I never actually use this node. I usually delete that. And whenever I want something to have an overlap event, I go up to the components tab, and then I type in collision, and you've got different types of collision here: box collision, sphere collision. I think sphere collision is probably the easiest to use because it's only got one variable, which is the radius. It uses less data than the cubes, which have three different lengths. So if you're gonna have lots of them, I think it's more performant. But anyway, I was just talking about not worrying about performance, and here I am already like ranting about shit that is just unnecessary. But anyway, if you right click any sort of collision and then go add event, you can see that you've got a bunch of different events for these as well. So for example, where's the begin overlap one? Add on component begin overlap. That's the classic. It's like whenever this sphere overlaps anything in the game, overlaps are a great driving source of events in games. Whenever it begins overlap, then we're going to execute a chain of events. So maybe that's what we could start with. When overlap, most basic thing in the world is just print string and just say hello. Whenever you want to just test something, I usually just chuck a print string in there. And so now to test that, if we put our BP events in there, we're going to jump in and we're going to walk over it and see if it'll overlap. Now, before we do that, what was I going to do? I was going to make it visible in the game. So if you click on the sphere and then you go to, I think it's hidden in game. The overlap events by default are hidden in game. The overlap collisions rather, because obviously you don't want to be able to see them when you're playing. They're just there. And I'm just going to make it a little bit bigger. And I'm going to make the line thickness a little bit thicker as well, just so we can see it nice and clearly. So that's a bit intense, but you know, who gives a shit. Now if I go ahead and click play, you can see that's our collision there. And then if we walk into it, you can see we get the overlap event because it's began to overlap with an object. And you could push physics objects into it as well. So maybe I could quickly give you a demo of that. If we quickly create a new blueprint class of type actor, and I'm just going to call this BP physics. I'm just going to add a static mesh because it needs a static mesh component to be a physics object. It can be a cube, that's fine. We're going to start with simulate physics enabled, and I'm going to just drag that onto the default scene root because we want the center of the cube, the root component of, or the root of the cube, to be the root of the actor itself. Otherwise the cube's going to fall out of the sky, and then, you know, it might trigger an event like way over here or something, and then you say, oh, let's spawn a particle effect on the cube. The root of the cube's going to be way over back here because the root won't have physics simulation enabled unless the cube itself is the root. So I hope that makes sense. If it doesn't, don't worry about it. All this sort of detailed shit makes more sense as you go along. But anyway, so if I put this up here now and then let that fall out of the sky, you can see we get the overlap event as well because the collision is overlapped with the cube. Now, this is a good point to demonstrate what some of these pins mean. Is overlapped component. Well, say you wanted to figure this out for yourself and you were curious about what the hell these are, you can just plug them into there, and then it can sort of give you an idea. So BP events.sphere. So, well, what do you think that means? The overlapped component BP events.sphere, it's probably referring to this sphere here. So when this event fires, you've got access to references. So in the second point of our diagram, we're saying everything starts with an event, and then followed by that is you need a reference to something in order to do something to it. So when this BP events blueprint with this sphere collision, when this sphere overlaps something, triggers this event, what is the overlapped component? Well, it's the sphere. So now we've got access to the sphere. We can destroy it. We can get world location. We can get radius? No, we can't get the radius of the sphere. I wonder why. Very curious. Well, the reason why is because overlapped component is a... This is sort of getting into maybe a little bit of the weeds, but maybe this is interesting to explain anyway. If you hover over them, you can see that it's a primitive component object reference. And we know that it's a sphere collision because we put it in the thing here. But this overlap event is sort of a more generic node that doesn't actually know that this is a sphere, because it could be, it's an overlap event for, it could be a cube, it could be a fucking triangle, it could be the shape of fucking Albert Einstein, like, you don't know. It's just basically, it's this generic overlap event. And so if we go from here, this is where you introduce what are called cast to nodes, which these aren't, you got to be careful about how you use these because they can make your blueprints not necessarily scalable later on, but we're going to talk about that. And if we say cast to sphere component, right, and then we use as sphere collision, we can then go ahead and say get the sphere radius. So you know how we set the radius over here, we can go ahead and get that. Now this cast to node, you can see that it's got execution pins up there. If you right click and convert that to a pure cast, you don't actually need to plug in the execution pins. And so now if we just drag all this over here and then plug the sphere radius into there, basically what this code is saying is that when this BP events, when the sphere component overlaps anything, then get the overlapped component, which is the sphere. We're going to cast to a sphere component because the graph doesn't actually know that it's a sphere, but we're saying, well, assume that it's a sphere. And then assuming that it's a sphere, get the sphere radius and then print that to the screen. So if we go ahead and then jump in now, you can see that it spits out 512. So yeah, just interesting little tidbit on variable types and casting and the types of information that you can access from things. So, you know, you can drag off here and you can say get, you can get all types of things from what is a generic overlapped component. And, you know, you can get transforms, you can get locations, you can get whatever the hell you want. And if something isn't showing up on here that you want to get, so you can see we've got more stuff down the bottom. You can get tags, you can get is it visible. These are all properties of the generic variable type primitive component. Okay, but we'll talk more about that later. This is sort of detailed, but you know, stick with it and we'll get into more of these weeds later. But there's a bunch of different things that you can get. There's probably a bunch of different things that you can set as well. Like you can set active, etc, etc. But basically, if something isn't showing up in there, you say cast to, and then cast to the type of object that you want to actually work with, and then you can go from there. So anyway, after that little tangent, let's talk about probably a more practical way to use the begin overlap thing. So we looked at the overlapped component. Let's look at the other actor. So again, like if you were curious about what that actually was, or you wanted to debug or whatever, you could just plug that into there, and then we can let that drop, and you can say it's the other actor is the BP physics cube. Okay, so that's the actor that has overlapped the sphere component. And so let's just say when it overlaps it, say this is a kill volume, we just want to destroy it. So easy enough, right? Drop in, boom, it's gone. And then same thing will happen to us. Killed us, we're gone, we're dead. And so then again, the other component, so this is something interesting about the overlap events, is that the overlap doesn't actually occur on the actor itself, it occurs on a component, and then that component has an owner, which is the actor. And so if you were curious, say like if your physics component had like the cube, which has its own overlap on it, but then it also has, let's use a box collision this time. Say it also has a box collision which is like bigger than the cube itself. What you're going to notice now is we'll probably get two overlap events. You see we got 1, 2. We got the box first and then the cube second. It's because there were actually two events that fired from this node. The first one being the box here, and then the second one being the cube here, because this event fires every time it overlaps a component, not just an actor. So, you know, that's good to know. And so then, depending on the component that it overlaps, is then you can do different types of logic. So say let's do an example with a character. So say we want, when an overlap occurs on the sphere collision that we've got here, our BP events, let's say we only want it to affect characters. Well, we just introduced the cast2 node before, so let's type in cast2 character, and you can see that we've got this execution pin here and we've got the cast failed. So what this basically means, this is sort of functioning like a branch. It's saying if the object that you put in here is a character, then go ahead and execute your print string or do whatever you want. If it's not, then, you know, do something else or do nothing. So in this case, if we go ahead and hit play now, you can see it's doing nothing for the block because it's not a character, but for us it triggers the overlap event. It gives us the little hello in the top left corner. So that's an example of the cast2 node acting as a branch. And so now let's say it overlaps the character. What if we wanted to do something to the character? We'll get it to launch the character. So this is a fun little node that I like to use a lot. Let's just fucking yeet ourselves into the sky. Alright? Because why not? Let's have fun. We've been doing boring shit so far. Boink. Oh, you got to enjoy the small things in life, you know. Oh my god, it looks like we're clipping through like the sky sphere or something. I love the shadows on this new version of Unreal and the lighting. It's actually quite beautiful. Oh wow. Oh god, we've fucking escaped into the void. Your scene contains a sky dome mesh with the sky material, but it does not cover that part of the screen. This is like I love this sort of shit in games. It's like when you play a game and it's like you break out of the simulation and then end up in some place where it's all computer code and ones and zeros and makes you feel naughty. So anyway, back in the event graph, there are a few other pins there, but I'm not going to go through them all. Basically, every node that you use inside the game, inside the engine rather, they've always got a bunch of different things that are sort of specialty options. What's this one? There's a multi-box trace by channel, for example. Like, you know, you might not always necessarily understand how to use them all, but if you're not sure, you can just sort of leave them as a default or fiddle and play with them, or you know, you get curious the more time you spend developing, and you might be looking for a specific feature to do something that you're trying to do, and then you might start looking into these different pins, but you don't need to understand every single pin or how every single node works to basically get into making a game. So that's just something to mention. But anyway, that's probably enough with the component begin overlap node. Let's have a look at some of the other events and do some quick examples about what you could potentially do with them. So before we do that, let's add some content to the game so that we've got some things that we can actually play with. Oh my god, I'm still up in the sky. Just a quick tip, it looks like I've got my physics cube highlighted, so if I press F now, that's going to zoom me all the way back down. So that's good for navigating through the game. If you click something up in your details panel and then hit F, it'll zoom you to the thing. Just a neat little trick. So let's add some starter content. So if we go into here and then let's see if I can remember how to do this. I thought I would write, oh, maybe we've got to go to the content browser here. And then if you right click, yeah, add feature or content pack. If we go content and then add starter content, I wonder how long that'll take or if that'll just be instant. Oh, it looks like it was pretty instant. So this will just give us some materials and some objects, and I think maybe even some music to play with. You can see we've got the starter content here. Audio, yeah, we've got some explosions and some sick music. All right, so let's explore some of these different events. So begin play, self-explanatory, works when the game begins, or when play begins. So let's say some nodes that you might want to use is spawn actor from class. Self-explanatory. I'm not going to go through them all at the moment anyway. You might want to spawn sound 2D. So maybe let's do some intro music. We'll play what if I just type in music? Starter music. I'm going to turn the volume right down. So, you know, begin play. Music's playing. I don't know if you can hear it or not, but I can definitely hear it, and I don't want it to be too loud on the stream. So begin play, self-explanatory. Event tick. Let's have a look at event tick. So a good example of this is firing every single frame. So one way that you might want to do this is, well, let's just do a really quick and dirty example. Using our logic that we did before, we've got an event firing. What we're going to do is we're going to print the location of the character every single frame of the game. Just for curiosity's sake, like say you wanted to get your coordinates of your character in a Minecraft world or something, the way that you would do that is get their transform and then divide it by like a unit size. So we've got the event, it's firing. We're going to think, how do we get a reference to our player character? Well, you just literally right click in the graph and then you can say get player character. There are a couple of nodes like this to help you just get foundational things to the game. So get player character is one. Get player controller is another, which is different from the player character. We'll get into that later. Get player state is another. You can get the game mode. You can get, I thought you could get the HUD. Or maybe in order to get the HUD, I think you might have to get the player controller and then say get the HUD. Yeah. So, you know, there's plenty of different things you can get game instance, so that's another different thing that we can use. You can get the game state, which is one that's used in multiplayer quite a lot. These are just like default sort of things that are just accessible anywhere. You can call these nodes from the HUD, you can call them from an actor, you can call them from a character, you can call them often in like save games, all different types of different assets. So this is a great way to get references to things and then in order to do something to them. So in the case of our event tick, we've got our event tick, which is firing every frame. Let's say we want to do something with the information that we can access from the player character. Maybe we want to get the location. We'll get the actor location, and then we'll do a print string, and we're just going to print the coordinates. You could display this on the HUD or something. We'll get to that later, how to do that exactly. And just in here, what if I just say append? Or maybe let's go to format node. No, we can't do that. Let's say append. Formats for text. And we're going to say location, colon, plug that shit in. And then you can see every single frame, it's giving us our location in the game. Now, people are going to warn you about using the event tick. They'll say that, oh, you should never use the tick because of bloody performance or blah, 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 blah. It's true and false. Obviously, because it's firing every single frame, it can be performance like exhausting if you've got a lot of shit that's running on it, but you know, sometimes you want and need something running every frame. If you don't, then here's an alternative. If you don't need it every frame, here's an alternative. What I'm going to do is take the logic that I'm using on the event tick, I'm going to right click, say collapse to function, and say print player location. I'm just collapsing that to a function so that I can easily just use it somewhere else, and then I'm just alt clicking to break that pin just there. Say we wanted to only update the location like every second rather than every single frame. Well, how the hell do you do that? We use a thing that's called a timer. So the way that we use a timer, we use this node which is called set timer by, you can use function name or you can use event. By default, I always use the event one because I don't like manually typing the names in for the function. So if you say set function by name. You've got to put a name in, and then you've got to copy the name of the function down there into there. But then sometimes I like to change the names of things, so I don't like to do that. What I like to do is I use set timer by event, and then basically what this does is then you can drag off this event pin here, type in custom event, and then this event is going to fire at at the interval that you put in here. So say if we put 1 second in, we make it looping. This custom event, we're going to say, I wonder if I should actually, rather than having a custom event, we'll just do it like this because it's easy for now. Let's just plug that in there. And then we need to tell this node to actually initiate. So we're going to plug it in to begin play. So, when do you want this to start? What's the event that is going to trigger your timer? Well, we're going to trigger it at the start of the game. So let's just plug that into there. And then every second, we're going to print the player location. So waiting 1 second, there you go. You can see it's printing the location every second up in the top right. So that is a more performant way to do something that might be, like intensive on your performance. And you can also, this is introducing a new concept here, is the concept of variables. If you wanted to have a variable time, you could just drag that off there and say promote to variable, and then call that location update tick time. And then make that public down there. And basically what that does is by clicking that little eyeball down there, is that you can go into your editor now over here, and you can click on your our BP underscore events, and we can change the time here. So if we want to manually make this one faster, as you can see now it's going every 0.1 second rather than every 1 second. So one more thing that I'll just show you is this is clumsy like this. We don't actually need a custom event there. We can delete both of these, and we can drag off of this and say create event. And I'm just going to put this under here so it's neat. And then basically this gives you the option to select a function to use as the event that's plugged into this. So it's again, like the pins on here, they're all asking for information, and the information that you're giving it is which event do you want to have triggered by this timer every 0.1 second or every 1 second or whatever. And so let's give it an event. We'll say you can create one. Even if you click create matching event, it'll literally generate an event, and then you can say, oh, we want it to do this, and then type in blah 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 blah, do all this fancy shit in there. I'm going to delete that, and now that's giving me an error because it's like, bro, you just deleted my event. But if you scroll down, you can say print player location, and then if I hit F7 to compile and save, by the way, if you're wondering how I was doing that, you want to hit the compile button up there, and then Control Shift S. But I just hit F7 and that just compiles. That's how you feed it an event. You can use this create event node, and that's nice and neat, and then you don't have to drag that pin off and have like more like bullshit spaghetti code. So if we jump in again and play, every second it's gonna, or every 0.1 seconds, it's gonna print our location. It's printing every 0.1 seconds because we've got this set down there. So we can go ahead and reset that, and that's how you use event timers. And so there is another way that you can use event timers. So this is updating the location every tick, but say we wanted to have something like a match timer where you've got like 3 minutes in a game. How do you do that before the game ends itself? So again, you'd say set timer by event. Again, what do we want to have happen? Well, let's say we're making a timer. We're going to say create custom event. We're going to create a match timer, so the game ends after 3 minutes, or in our case probably like 3 seconds. What do we want to do? Let's create a new matching function, and we're going to call this end game from timeout is what we'll just call that. Just, I don't know, sort of makes sense. And when this runs, we're just going to quit the game. So that's another interesting node that you can use. Good to know. As you get familiar with tutorials and developing, you'll always be coming across new nodes. There's always shit added to the engine, and depending on the type of work that you're doing, you're going to like watch tutorials and get in forums and things, and then come across nodes that you've never heard of, and suddenly become aware of all new things that you could do in the engine that you never thought were possible. So if you ever see a node that you're not familiar with, like, don't be intimidated by it. Even if it's got a lot of pins, it doesn't matter. Just you can hover them to read them to sort of understand what they do. But you know, like even if you're just like looking for something sort of specific, like for example, I remember one day I used to just use the line trace by channel, and then I thought, well, what if I didn't want to use like a visibility channel, but I wanted to use like, say, the object collision, like world static or whatever. And then I learned that there was a line trace by object type. There's a line trace by profile that takes in different collision settings, and then you go ahead and research, well, what the hell does this actually mean, and how do I create collision channels, and like whatever. And then you suddenly got new tools in your toolbox. So yeah, it's your repertoire of different nodes that you can use sort of comes from experience, and as long as you've got like the foundational knowledge of what I showed you in my little drawing of like event, reference, node, and then do stuff and give it input and then feedback and then whatever else, you can just constantly add new stuff to your list of nodes. So anyway, you can also get plugins as well. So that's the other thing, is if you import plugins to the engine, from up here. So I don't know, some of them are enabled, whatever. I don't really want to find one right now, but basically once you enable that and you right click in here, suddenly you'll get a new category, and then that'll give you access to new nodes that you didn't have access to before, so that you can get the engine to do new things that weren't actually in the engine itself but had to be plugged in. So that's a quick description of what a plugin is. But let's get back to our match timer. So again, let's promote the time to a variable, and we're going to call this match length before game over. I like to make everything variables that I think I'm going to change later or reuse in a different place. So I'm just going to make that public again. And let's just say it's like 5 seconds, okay? So the match length is 5 seconds, which is a bit short for a game. But, maybe it's a really intense game and you can only handle 5 seconds before you're like crying in a pool of tears on the floor. Like my games. So on begin play, we're going to start that timer, and then when that timer finishes, it's going to execute that function. And something else that I like to do, so I'm just going to move this out of the way. I can delete that one now. In order to easily find that function, is what I like to do is I just drag it on top of the thing just there. So whenever I'm like revisiting my code later, rather than like reading that there and then having to trawl through a list of functions down there, I can just double click up here and see what it does. So just a little tip for you. After 5 seconds, it's going to quit the game. All right, so let's see if that works. 4, 5. There you go. Works like a charm. And I counted it pretty accurately as well. So that's how you use a timer. And something else that we wanted to do is, something else that we could do rather, is you can get a reference to this timer. So we can promote that to a variable. I'm just going to call that timer reference match end countdown. And so now we can get this in other places to get information from it. So this sort of becomes a little bit similar to how we were talking about the components before, and we could get the radius and whatever from it. If we come over to our event tick and then every frame, let's get a reference to our match timer. Can we say get timer remaining time by handle? So that sounds kind of cool and interesting. Oops. If we print here, every frame we can now print the amount of time remaining before the game ends. Check that out. So we've got a countdown up on the top left of the screen. Boom, just like that. So that's an introduction to timers. So that's some of the main events that we can sort of do just off the bat. I'm just gonna, maybe I'll leave a couple of these here for the people who get the project files so that you can sort of go through them and just see what's here. We'll keep the destroyed one there as well. It's interesting. We'll keep the end play one there as well. That's also interesting. But let's now jump over to what's called the construction script. Now this is purple because it's not quite red, but it's like something between sort of blueprint and event. So basically this node happens before begin play, and things that happen inside of the construction script actually occur inside the editor view before the game even actually starts. So hence construction, because this fires in the object's construction before the game actually begins. So for an example, maybe we can use the physics cube for the construction script. So if we come over to the construction script for the physics cube, let's get our cube and then let's say set material. And then we can plug in, say, this like pink material. Now, nothing's happened yet because I haven't compiled it, but if I hit compile, it runs the construction script, and now you can see that that's purple. And then same deal in here, that's purple. So that's the construction script. Now, there is a bunch of stuff that you can do in the event graph that you can't necessarily do in the construction script. Like, for example, if I say spawn actor from class, nothing is going to come up in the construction script. But if, say, I was going to run that on begin play, then that node shows up and I can do it. So there are a few situations where you can do something on begin play that you can't do in construction, and probably vice versa. I don't actually know. Maybe there's stuff that you can only do in the construction script that once the game has begun, then you can't actually edit on begin play. Maybe that's true, but people, it can be kind of confusing to distinguish the two. It's like, well, this happens when the game begins, this happens slightly before the game begins. What are the use cases for both? This is stuff that you want to do before the thing actually spawns into the world. So maybe you want to, say you're spawning an enemy and you want to determine its health or something from a data table. So down here, this is another example of the getting references to things. Step 2, when we're getting references to actors, we can also get references to, say, data tables, data assets, and different ways to store data in order to drive our blueprints. So I'm going to do a whole video on different ways to store data, probably later on. And there's also a video on my channel called Smart Data Storage. You'll be able to find that. I'll put it in the description as well, where I talk about different ways to store data. But let's just talk about one. Let's say you get data table row. Or, sorry, not that one. Let's say get data table. Where's get data table row? Down here. Get data table row, and say you had enemy health or something in there, and then you had this structure here, and you broke that into a float. You could then set the enemy health in the construction script before the thing actually spawns into the game, because if you did it at begin play, there would be perhaps a frame where the variable hadn't actually been set yet, and so that can sort of cause glitches. It's like some things you want to do before something is actually incarnated into the game. So that's just something to think about. We'll probably do some more examples of that later on. But yeah, that's sort of an introduction to the construction script. A good example of stuff that is usually done in the construction script is... I could just show you in here because I'm not actually going to build it. But say if you've got an instanced static mesh, basically what that just means is a static mesh just like the cube that we've already got here, but when it's instance, it's got one mesh, one material, but then multiple instances of the cube. So say if you were going to do something sort of Minecraft-esque, is that you would have your instant static mesh here. You'd run some for loops. You'd run a for loop inside a for loop like this, and then add a bunch of static meshes to it to populate a grid. And then you'd do that in the construction script before the thing actually spawned in the world, so that it was ready to go. So that's just a use case. Okay, so that's sort of a little overview of the different types of events that we've got in actors. But let's have a look at some of the other classes. So now in our blueprint fundamentals thing like this, how before we went right click, blueprint class, and then we created an actor. We can also create characters. We can create all this other stuff. Rather than create a character here, I'm just going to go to the character that we've already got just for now. So if you go to content, third person, blueprints, and then third person character, inside here, this is all the movement and input and shit set up for the third person character. But inside of here, we've actually got a few nodes or few events that we can use that aren't actually accessible inside of actors. And the reason for that is if we go back into here and we go to create a new blueprint class, and you read these, it's like actor is sort of like the basic of the most basic class. It's sort of the most generic. It's got no specialization whatsoever. It's just something that you can just place in the world and then add a viewport to, visual component. You can add a construction script and an event graph. That's basically it. And then sort of as you go down to pawn is like a specialized version of an actor. And it says here, it's an actor that can be possessed and received input from a controller. So actors can't be possessed and receive input. So if you're going to be making a character, it's very important that you use either a pawn class or a character class. And I always use character classes because, to be honest, I don't make games that use pawns. I use characters because they come with, you can read it. It's a type of pawn that includes the ability to walk around. So pawns by default, they don't come with any of this stuff, which allows you to walk. It allows you to look with the camera. It allows you to jump. It doesn't have this character movement component, which actually does quite a lot of stuff under the behind the scenes, like in the game. So I always opt for character. But basically, back in here again, you've got actor, which is the most generic, then you've got pawn, which is specializing, and then you've got character, which is specializing even further again. And you can even make your own character subclass, like, of the character in here. So if we were to create a character, you can see that we've got the character movement component. This is all the stuff that comes with the character blueprint just by default. You can even create your own character blueprint class, which is this one actually, because I've just created it. This is a child. You can see it on the screen just there. You've got blueprint at the top, and then you've got character beneath that. You can see that the parent class is character. So, this is where you do the logic for your main character, and say you wanted to even create a child blueprint class of that. You can go down and you can see that it's got new blueprint as the parent up there, because new blueprint is the name of the character. So that's sort of how inheritance works, but maybe we'll go into more detail about that later, because that's not really that relevant yet. Where was I before that little tangent? So basically the point is that the character blueprint is a specialized version of the actor blueprints, which, because it's specialized, comes with extra functionality, which also then exposes different sort of events that you can use, to drive custom logic. So in order to access those events is if you just want to browse them, even you can click up here. Let's have a look at the different components. If you click on the component, you can say add event, and you can see all the different events for the component. So we looked at some of these before. You know how we had add-on component begin overlap. So this is already inherent in the capsule component. In the blueprint events one, we had to add a sphere collision and then say add event, and then click on the add overlap event for that. Because we've already got a capsule collision here, we can immediately click on that and then say add an overlap event for the capsule. So this is just works the same just as the blueprint that we did before, but now when the capsule overlaps something, we can use this pin, which is the other actor, and say, well, what did it overlap? So for example, say you wanted to have like a radar on your character. One way that you could do that is you could add a sphere collision like we did before, and then whenever the character's sphere collision overlaps something, you could drag off the pin here and say, well, this is what it overlapped, alert them to enemies or whatever. So that's one use case of that. You can also use the capsule collision for on component hit events. Yeah, so on the top there. So whenever it like bumps into something, when it hits or is hit by something solid, so if you walk into a wall or whatever, you can say, well, what's the component that got hit? It's the capsule component. What did it hit? Which component did it hit? Remember how I was saying that overlap events occur with a component that has a parent? So you get the component, which is where the collision actually occurs, and then you can get the parent of that component from there. You can say what was the impulse of it hit, and you can actually break the hit result there, which is something that we'll explore. We'll explore hit results later perhaps, but you get a bunch of different information there about what the hit actually was, and then you can determine what to do with it. So that's just something to look at. The reason that I'm sort of just breaking these down and looking at these different events is to just make you aware of like just generally what sort of tools are available. You don't have to use all of this, obviously. Just because, you have all this like technical knowledge doesn't actually mean that you have to use it to make a good game. Oftentimes, it's actually the simpler shit that is actually more fun to play. And just because you've got a lot of tools in your toolbox doesn't mean that you need to use them all. But it is good to sort of be aware of what is out there in case there is some specific functionality of what you're going for. You can sort of browse through the different events that you've got available, and then they sort of become the different paints or the different brushes that you've got on to use on your canvas. So for example here, like for the mesh, for example, there's a bunch of different shit here that I don't even know what these do, but constraint broken sounds interesting. Plastic deformation sounds interesting. On initialize, that kind of sounds interesting. Like maybe that runs when a new animation starts or something. Who knows? What have we got for the camera boom? Something about physics volume changes. You could look into that if you're interested. Again, same there. What about for the character movement? So nothing there. But there is some stuff that is available specifically to characters. So in order to get those, it is a little bit different to what we did last time. I'll show you how to do it. So I wonder if we've got a begin play here. So it looks like in the new templates on event possessed, well, that's already a good event to be aware of. When actors begin play, you don't have access to an event possessed because they can't be possessed. But when you've got a character blueprint, obviously they're going to be possessed at some point by a player controller. And so it's good to know that there's an event possessed, which then when they're possessed, you can go ahead and you can do the input, set up their inputs for them. So that's good to know. Now, there's also event unpossessed. Let's just go through the different events. We can say event receive restarted. So if you hover that, event called after a pawn has been restarted, usually by a possession change. Well, that's good to know. So say if you change character in your game, then that's going to fire. Cool. Event update custom movement. So no idea what that does. Maybe that's just occurring every tick. Who knows? What else have we got? Oh my god, there's heaps of them, dude. Look at this. It's even more than I thought. So, all right. So let's let's go through some of these, and we'll just see what you've got in your toolbox. So I saw event on landed. So that's good to know. When your character lands, let's this could be fun. How about this? I've never thought about doing this before, but let's say we wanted to make a trampoline game using the launch character node. Let's launch you up by 1000. We'll Z override. We're not going to XY override because we still want to be able to move. But let's say every time you land, we're going to launch you back up into the air. I wonder how that's going to go. Check that out. We've now got a game that's a trampoline. Oh, and then of course it ended after 5 seconds because of our timer here inside of our BP event. So we're going to get rid of that. I'm going to turn off that tick as well because we don't actually need that anymore. But yeah, man, like this is sort of interesting because this can help you drive gameplay. It's like, what is a game basically but just a bunch of different events which then you do things off. So, you know, we've now got pogo stick gameplay just off one event and one node. And then of course you want to add feedback to that, which was, remember how we talked about that, to make the game feel juicy and immersive and whatever. So you could spawn a sound, like do we have like a bounce or like I don't know, let's just use that because I don't really give a fuck right now. I can't be bothered browsing through them, but let's, you know, for demonstration purposes. And of course you could spawn particle effects and like whatever, you know, that's game design, dude. So let's see what else we've got. Event, I think we used unpossessed, receive restarted, possessed. So look, we got start crouch, end crouch. We've even got one on launched. So you know how we're using this launch node over here. You can see that it takes those 3 inputs. Whenever this is fired, there's another event that fires, which then, you know, maybe even here you could use your, you could spawn your sound effects. So, for example, rather than just having the sound effects occur over in this execution chain, if you put them here, then basically you could add an actor into the world that sort of acts like a bouncy enemy or something, which also has a launch character node inside of it. And so then whenever that launches the characters, you could actually put the feedback in here, put the feedback in the character itself, and then basically you could have 100 different types of actors throughout the world that all launch the character, but you only need to put the feedback in one single place, which is here. So this is where we sort of, you know, get into the territory of you sort of call it game design or game development. I don't really know what you call it, but it's like the technical sort of shit that people don't think about when they when they play a game. It's like you sort of get into a game, and if you're a gamer, it's like the game either just works or it doesn't, and it's like, you know, you think it's buggy or you think it's smooth. But all of the systems that go into a game, there's a massive amount of logistics that go into making sure things are modular, making sure that code is reusable, making sure that your systems are clean and intuitive and easy to build upon, and etc. And so that's like a whole art of like blueprints. It's like and sort of something that comes through experience, I suppose, and through experience over long periods of time when you work on a project for, you know, weeks and months and years, is that you sort of get an idea and a feel for how to do your blueprints in a way that is going to make them easily reusable, easily able to like build upon them, and not end up with like a tangly spaghetti mess of just like hacky solutions that are then very difficult to scale because you've got to be copying and pasting code. So, you know, that sort of just comes through experience, and you'll get a bit of that experience as you go through this course. But the best way to get that experience is to just make games, man. And, you know, just learn through experience. And so just another couple of nodes that we've got here, just to go through them. We might as well, since we're here. Event received control. Oh, we've already got that there. Received controller change. This would be a good opportunity to add like a HUD or something. You can sort of read what they've done here in the comments. So that's interesting to help you explain what's going on. The other project examples, like the third person one and the side scroller and whatever, will have some interesting comments like this, no doubt, to explain what's going on. There was another event here, which was, we did receive controller change. So there's crouching on, so we start and end crouch. So for example, you could, I don't know, change the sounds that your character is emitting, or change the height of the camera, or, you know, just shit like that. There's this one here which is on movement mode change. Now this is an interesting one. So just to sort of demonstrate what this does, this is sort of getting into more advanced like character movement stuff, but this is going to fire every time the character goes from walking to falling to swimming to flying to custom to nav mesh walking, etc. And this can be a good way to drive animations, actually, is that whenever the movement mode changes, so for example, when you're falling, you might want to play a falling animation, and when you're walking, you want to play a walking animation, etc. And if you look inside the animation blueprint for the character, which I don't actually know how to access right now, if I click on mesh and then click on the skeletal mesh here, and then if we go to the, I think that's the animation blueprint here. Oh, what the hell is this? There might be a blend space here. Walk, run. Oh god, who the fuck knows what's going on there? But basically, like, you can use the current movement mode of the character, so where they're walking or whatever, to change how they're animated. You can also change what your inputs do based on their movement mode. So, you know, if you input your spacebar when you're on the ground, you know, you might want to jump, but if you input it in the air, you might want to double jump or launch yourself forward or something, or pull out a parasol, or, you know, just shit like that. Or maybe if you're sprinting, you know, just there's different ways that you can do that. But just for example, if we just pull out our event tick again, just for demonstration purposes, and we just say print string and then get a reference to our character movement, because that's where your movement mode is. It's like, this is the object. We're going to say get movement mode, and then just plug that into there. You can read what your movement mode is. It's occurring every tick because we've got it on. Oh yeah, so we're going to be falling there because we're bouncing. But you see there's a frame there where you're walking again. But so that's reading what the movement mode is. But now whenever it changes, say we want to execute an event. Now this is a good idea to introduce a bit of blueprint logic. If we say switch on movement mode, or a better way to do that is if you say, well, what's the new movement mode? This fires whenever the movement mode changes. What's the new movement mode? If we drag off that and then say switch, you don't have to search through that whole list of bullshit that we just had before. And then we can drop this down. You can say, well, okay, if we're walking, then, you know, do something. If we're falling, do something else. So this is where you sort of get into branching paths based on conditions. You can plug that into there and then, you know, do whatever you want from there. So, you know, if you're swimming, make a splash. If you're falling, play some falling sounds. If you're walking, play some cool, like, walking music. I don't know. Heaps of different shit that you can do there. So that's just an introduction to the different types of events that are available in the character component. I wonder if there's any more in here. So you got when the component's activated, deactivated. Looks like you got some for AI as well. Oh no, they're not events, they're just functions. Anyway. Alright, so just a couple of other things that you can do some events in. If we go back to our content browser and go to Blueprint Fundamentals, let's just create another folder in here. We're going to call this actors, and I'm just going to put them both in there because they're actors. We're going to do some different stuff that is not necessarily actors now. Let's create a new blueprint class, and this is going to be of type game instance. So game instance down there, and I'm going to call this GI for game instance, blueprint. Oh, what if we just call it fundamentals? I didn't even spell that right, but who even gives a shit? Now the game instance. So I suppose it'd be a good opportunity now to introduce a couple of different asset types. But the game instance is the very first thing that's created when the game runs. It's running at all times throughout the game. It's basically the game itself. And so even when you're transitioning from one level to the next, you're transitioning from one player to the next, through this map, through that map, through menus, through whatever, the game instance is always running, and it's always the same thing, and it doesn't exist in any of the worlds. It's sort of like the meta of the most meta. It's like the biggest overview container of the whole game. And so that can be sort of interesting to know about, because there is some stuff that you want to be able to do at all times, regardless of what map you're in, regardless of what players you're possessing, etc. And the use cases of that you'll become aware of as you do more game development. But just to start, let's just have a look at the types of events that we've got here. I wonder if we've got some functions. So yeah, let's have a look at this. We've got init, we've got network error, we've got shutdown, and we've got travel error. So I think these might even be the 4 only events that exist in here. But basically init, this is the thing that we're just going to look at now. You can learn what the others do if you're curious. But init, opportunity for blueprints to handle the game instance being initialized, whatever, that doesn't really make much sense. This is the very first thing that fires when your game opens up. I don't know if it's actually the very first thing, but it like sort of is. It's like way at the start. And so sometimes what I'd like to do in my game instance is I like to set the engine scalability settings. So if I say set, is my keyboard going to work? It seemed to glitch out there for a second. Set, oh my god, is my keyboard like broken? Set scalability quality level relative to max. So, you feed this a value. 0 is cinematic, 1's epic. I think, they go up to like 4 or 5 or something. But, maybe what you want to do as soon as the game loads up is that you can get or load game from slot. You can load the graphics settings that the player had when they closed the game, and then you can immediately initialize that as soon as they open the game. So maybe on event shutdown here, this is where you could put save game to slot and get their current graphics settings and save it to their hard drive. And then when the game begins, you could load the game from slot and then restore their graphics to the last one that they had it at. Now, if you want a tutorial on how to do save games, I've got a video on YouTube. It's called Streamlined Saving and Loading. You can find that on my channel. It's in the Blueprint Fundamentals playlist, and I'll see if I can remember to put it in the description as well. But basically in that, I'll show you how to use the different save game nodes and to do a saving system so that you can easily store data. But anyway, so that's one example of how you could use the event init node. You could set the scalability settings. You could also get the game user settings. So here are some more Blueprint nodes for your little toolbox. Get the game user settings, and then you can do things like set window default window mode, or what is it? Set full screen? Yeah, set full screen mode. So you can set the different window types. So do you want your game to be full screen? Do you want it to be windowed full screen, or do you want it to be windowed? Like, that's kind of cool to know, right? Like, that's not even necessarily related to the game itself. This is sort of the meta stuff about how the game runs on your computer. And then after you do that, you need to say, I think it's save settings. Or is it like push or something? I don't know. Maybe that works. Well, why don't we test it? We could probably test it, right? But before we can test it, we actually need to tell the game to use this game instance because it's not even using it yet. So if we go to edit project settings and then go, no, where is it? It's in maps and modes. Yeah. So here's all your sort of startup shit that is like fundamental to how your game actually runs. So you got a default pawn class. That's one of the most common ones to change. And then the game mode up there, that's another one of the most common ones. And then if you scroll down, you got the game instance class. So if we go GI fundamentals, because I spell like a retard today. If we jump in now and play, it didn't look like it actually did anything, but I wonder if we add a print string, we can see if it was actually firing, because that's the first thing to do when you're troubleshooting. So it is firing. I reckon I needed to hit apply settings. I reckon that's what it was. Apply settings. Let's try that. See if that works. I wonder if this actually worked as well. What if we set that to like 4? So we'll try and go real like dog shit, low quality, and just see what happens. It looks basically the same. It doesn't look like we're in a window mode either. What if we go with this one? It's not really changing anything, is it? What if we try full screen and see if that does anything? No, it's not working. Give me a sec. I'll see if I can figure that out. So anyway, I had a little bit of a play with this. I didn't have that there before. It looked like this. I don't know what the hell is going on here. This doesn't seem to work in the editor. Maybe this works in a packaged game and not in the editor. I don't actually know. There might be some sort of override in the editor itself. And the scalability node as well actually doesn't seem to work either. It doesn't change anything. But if you say, if you use the console, execute console command, and I think if you type scalability, what if we type in scalability 4 or something? Let's see if that does anything. Yeah, those other nodes don't seem to work, so let's just try this and just see if this actually does anything. Okay, so that looks like it might be the max graphics because I'm getting like 40 FPS at the moment. If you want to see your FPS, you hit the little tilde key, which is right next to your 1 key on your keyboard, and then type in stat FPS for the FPS counter. Stat FPS, and you can also go stat unit for the rest of that information as well. So it looks like that might be the maximum graphics. Now what if we type in scalability 0? Let's see what that does. See if the FPS goes through. Yeah, you can see that's much lower resolution now. So it seems like the console command is working better. Now, something that I did before was I set the frame rate limit. So even though this full screen mode doesn't seem to be working in this editor version, if you drag off the game user settings, so this is getting a reference to the game user settings, and then you type set frame rate limit, just like I've done down here, you can actually cap the FPS on your game. So this might be something that you have in your options menu, for example. You can have the player set an FPS, have it saved to the save game, and then when the game boots up, you can set the FPS limit. So if I set this to something just like random as hell, like 42, you can see that this is actually working. So you can see the FPS is 42. So that means that the game user settings is setting the frame rate and then it's applying the settings and it's working. But I don't know what the hell's going on with the full screen node. Anyway, this is the game instance, and this is some of the events that exist in it, and this is an example of what you could do in it. Now, I suppose the next thing that we might look at is probably, we'll look at the game mode. So if we go to blueprint class game mode base, that one's just there. So if you go gmb underscore, we'll call it fundamentals, and I'll try to spell it properly this time. The game mode is basically something that applies to each like world in your game. So we're in a world right now, we're in a level. You can see we've got the level here, and it defines, they describe it as defining the rules of the game. So if you go to the world settings, you can see that you can put a game mode override in here, and then, you know, maybe you've got one level which you want a menu game mode because the game is basically you're on the menu. You can have another map where you might be playing like a team deathmatch or I don't know, whatever the fuck people put in games, where, you know, the rules might be you play as a pawn, or it might be you play as a point and click, or like whatever. You define all that sort of in the game mode, because inside the game mode you've got access to your default pawn class. So what are you going to be playing as? What kind of HUD are you going to be using? And those are probably the main ones actually, but there are some other ones in there that you can play around with. But the point is that the game instance is like the big sort of meta container of the thing, whereas the game mode is sort of the next level of meta, where God, every time I say meta now I think of Facebook. Jesus. The game mode is sort of the next level of meta, where you get access to, for example, get player, or I think it's actually in the game state where you get this, but if you get the game state, you can say get player array, for example, and this is where you get all the players in a multiplayer game. So it's sort of got global access to a lot of different things. It's got global access to the rules of the game. So, you know, if something is, if you consider it sort of defining the rules of how the world actually works, like how your players spawn and like what happens when they lose all their health and etc., you sort of define them in here. Like this is probably where you'd put that match timer that we did actually. So you know how we did the match timer in our actors and we put it inside of here? This is actually something that you would probably put in the game mode, because like I was showing you earlier down here, how we've got this references thing, you can access the game mode. You can access the game mode from everywhere, and then remember how I showed you, you drag off that, you sort of get all the generic variables that are related to the game mode. If you then cast to the fundamentals game mode, now if you drag off this, you can get access to, say if we create a boolean here which is called playing, question mark, you can now get access to all of the variables that are inside our specific type of game mode, which we've called GMB_fundamentals. So the game mode is a good place to include things that you want to be able to access from everywhere, things that are related to how the game actually runs. And so in here as well, this is where, and so similar to how our player character before had access to events that were part of its sort of specialized class that is the subset of the actor class, the game mode actually has its own sort of special events that are specific to how a game mode runs. So if you go down here to functions and you see we've got this little override tab, I'm actually curious now that I've noticed that override tab inside of the game instance. I wonder if it's inside the player controller as well. So yeah, the player character, sorry. Inside the player character, you can see oh, look at this. We've even got some interesting functions in here that determine whether or not the character can jump. So that's interesting. What have we got? Can jump, destroyed, end play, hit, on jumped, event fire when the character has started jumping. You've even got an event for when the character walks off a bloody ledge. Check that out. So, okay, that's something that we weren't aware of earlier. So let's chuck that in there. On jumped, on become view target. So this is an interesting one. There is a node in the engine called set view target with blend. I think in order to use it, you need to get a reference to a player controller, because the player controller is sort of the player's interface with the game. It's like you're a human being sitting at the computer and there's a character which is inside the game. How do you communicate with the character? It's called the player controller. It's sort of an interface between the two. And so this is where you sort of your camera sort of resides, and it's sort of the lens through which you view the world. So anyway, if you say off of get player controller, if you say set view target with blend, you can set a new actor here that you want to look through the camera of. So if you've got a camera on your character here, which is like your follow cam in a third person view, and say you wanted to do like a remote viewing ability where there was a camera on another character over here or something, and you wanted to see their perspective, then basically what you would need to do is you would need to figure out a clever way to get a reference to that character. So for example, you could do it via an overlap event like I showed you earlier, or I'm going to show you a different few ways to do references in a moment, but you need to get a reference to that character, and then you set them as the view target, and then basically you can view the game through their eyes. So you can watch tutorials on how to do that if that's something that you're interested in for like spectator mode or whatever. But for the sake of this video, we're talking about all the different events that we've got access to. There's an event here, so when this becomes the view target, then you can get the player controller that is now viewing through this character's eyes, and you could run an event. So you could like change their HUD, or like you could tell them that I don't want you in my brain, get the fuck out of my brain, like stop possessing me and like reading my thoughts, bro, or like, you know, something funny like that. Anyway, so that's one thing that you can do. This is interesting. It's interesting to find all this stuff because I forget that some of this is in here. So whatever the hell point damage is, radial damage, you know, crouching, hit. Yeah, so there's interesting stuff in there that you can do that's related to the player character that we didn't discuss earlier. But anyway, let's go back to the game mode. And so if we go down to the functions tab here and look at what is possible for us to override. Sorry, we're not in the game. This isn't the game mode. This is BP events. Silly me. If we go to the game mode base _ fundamentals, and then look at what we can override. Most of these look the same as the other stuff, but you can see there are a few interesting ones. So we've got, see how it's got the little actor thing on the side. So these are the ones that are specific to all of the actors. So these are the ones that were accessible in the actor blueprint that we did before, whatever we called it. We called it BP fundamentals or whatever, this thing, the overlap collision. They're gonna share the same events here, but then you've got these special ones here which are specific to the game mode base. And so, you know, we've got this thing which is can spectate. I'll show you how to use these ones in a minute. These aren't events, these are sort of functions that run, so I'm just going to delete that from there. Can spectate, choose player start, find player start, get default pawn class for controller, handle new starting player. I think this one's an event, so let's click that. What if we say on logout? That's interesting. On post login, that sounds interesting. On change name, that's interesting. What else have we got? Player can restart. No, so that's a function. So let's not worry about that. What else have we got? Spawn default form for, yeah, okay, so that's a function as well. I think the rest of these might be, there might be functions. Oh no, we got initialize HUD for player. I think we might have a init start spot. I think that one is going to be a function. Yeah, so anyway, this is a short little list of some of the functions that are available inside of the game mode. So obviously you've still got begin play, so this is where you could set like a match timer or whatever. You've still got event tick, so you could print the countdown, for example, like we did in that previous example. Print how much time is left during the match, so you could do that on the event tick, or you could do it by a timer like we showed you as well. Now, handle new starting spot for play, you can just read through them. So signals that a player is ready to enter the game, which may start it up. And then you can see, well, we've got a reference to a new player here. So when the game is ready, this is the player that's starting the game. So that's an event that you could use. Now, these ones here are interesting. So we've got logout and login, and we've got exiting controller, and we've got new player. So basically, this is firing when the player controller enters the game, and this is sort of getting into multiplayer territory, which we might explore that in a different video. We're going to call that multiplayer territory. But basically, when a player controller enters the game, this fires, and it fires before they even possess the pawn. So what you could do is, off of new player, you could say like possess, and then give them a pawn to possess, and then delete all of these things here where it's like get default pawn class for controller and whatever. So this is not necessarily something you need to worry about if you're new to game development, but because if you're new, chances are if you just go into the defaults up here, this sort of stuff will be enough for a basic game. You can just set the defaults and you don't need to worry too much about the event graph. But it is good to know that these are here because, you know, maybe you want to do something when the player logs out. Maybe you want to do something when they log in. Like maybe you want to get their maybe you want to get, where's the player name? I think this is a player controller, so we need to say get player state, and then I think from the player state we can say get player name. So maybe you want to print a message for everybody in the game and say, oh look, such and such has joined the game, or such and such has left the game. So that's, you know, something good to know about. If they change their name, when they initialize the HUD, this event fires, so that's good to know. And when they initialize the start spot, you even get a reference to the start spot. So, you know, maybe if it's a multiplayer game, you want to destroy the start spots once somebody is spawned there, or, you know, something like that. There's lots of clever shit that you can do in assets like the game instance and the game mode, which help you make, you know, creative choices about the rules of the world that you live in. So that's just a quick introduction to the game mode and what you could potentially do with it. Now, as we were going through that game mode sort of stuff, I'll see if I can just pull up that game mode again because I just closed it because I thought we were done with it. There were a lot of overridable functions in here which sort of came up looking like this. So they weren't actually an event, a red event that you could then go and execute a bunch of things off, but they actually have a return pin here. And so the reason that these ones here show up in the event graph is because it's just the start of something. It's like, here's the beginning of an execution chain. Here's a bunch of data that you can do whatever the fuck you want with, but we actually don't care what you do, and we don't need anything from you. You can just take it, run with it, do whatever you want. Whereas some of these ones here, they have this return node, and so when it's saying find player start, I don't know when exactly this runs. I'm assuming it runs when a player controller has entered the game, they've possessed a character. What is the player start that we, or maybe what it does is it finds the player start before spawning the player character and then possessing it with the player controller. So anyway, it takes in a player controller, it gets the player's name, and then basically there's an output here, which is it's returning what is a player start. So I'm not going to go into the details of how to use that because that's sort of like technical, and like we can worry about that later when we go into multiplayer stuff. But for a simple example, a place where you might use one of those overridable functions is if you go into your BP third-person character and you go into override here, you can see that we've got this one here which is called can jump. And so basically now that we've clicked that, it's written here and you can see that it's got a little override thing there. So basically before we clicked override, this function would have had something in between here, probably written in C++, that is determining when the character can jump. So if I delete that right now, and I might just delete my crazy bouncing mechanic that we did earlier, because we're going to be doing some jumping in a minute. I might also delete that music, wherever the hell that was coming from. I'm assuming it's coming from this BP events thing on begin play. Yeah, because I don't know how loud that is and I don't want it to distract us. As you can see, I'm pressing space, can jump. But if I try to jump when I'm in the air, it's not going to jump twice, right? So it's got some logic. It's got some logic inside of that can jump thing written in C++ that is determining whether or not we can actually execute the jump command. So if I open this up and just say that we can always jump, I wonder if that'll just let me jump to infinity or if I'm going to look stupid. Yeah, so look, you can see it's overridden the rules that determine whether or not we can jump. And now I can just fucking jump whenever I want. So if you wanted to make a double jump, basically you could write some conditions in here that determine whether or not you've got access to a second jump. So, you know, you could count the number of jumps that you've done and then say once you get to 6 or whatever, then this is going to return false, and then, you know, no more jumping until you land. And then, well, okay, well, how do you know when you land? You use the event on landed and then reset the counter to 0. There you go. This is game design, man. It's like using clever events to make mechanics. Let's just have a quick look in here and see if there's any other ones. So you've got one for on jumped, end crouch. I wonder if there's any that have a return value. Probably not, actually. I think the rest of these are just basically events because they don't ask anything from you. It's the ones that have sort of a implied question mark, like can jump. You know, it's like those are the ones that usually have a return node because they're asking the character something. It's like, can we jump? And same with the game mode. It's like, can get start spot. Where's the start spot? Find start spot. Give me fucking... I was going to say fart stop. Oh, Jesus Christ. Anyway, next section. Okay, so just the next important asset class that we will go over is the player controller. So if you go blueprint, we've looked at actor, we've looked at character, we've looked at game mode base. Let's have a look at player controller. So if we go PC_fundamentals, can spell. Let's see what we've got access to in here. So we've got begin play and we've got event tick, you know, standard stuff that is classic for an actor. And as you can see, if you hover over it, target is actor. Now, if we go over to the overridable tabs, what have we got in here? You can see we've got a couple ones that are specific to controllers. So we've got possess, we've got unpossess, and we've also got receive instigated any damage. So this is sort of an interesting one. It's got this funny little thing up here, which is, this is a little damage icon. And basically, I've never actually used this, but I'm thinking what this does is it says, when this controller instigates any damage, this is going to fire inside the player controller and tell you how much damage it did. It's going to tell you the type of damage, I don't know what that means. It's going to tell you who it damaged and what was the cause of the damage. So just to explain what damage is, this is sort of this is getting into sort of interface territory, which we're going to explore in a later video. But let's just do for demonstrations. Let's say we had another character. Let's create a new character. This could be a good example to show you a way to do some references and things. We're going to create a new character. I'm going to call this BP. We're going to make an NPC, okay? We'll give it a skeletal mesh. What have we got? We got a Manny simple here. So we're just going to rotate him to face forward, face the arrow, and we're going to drop him down like that. Now, let's put him in the world, and we're going to make a very basic ability to do quote-unquote damage to him. So let's just make sure that he's here so we can see him here. Now, damage is a very abstract concept. It's like, well, what is damage? We sort of need to build a system for damage, which means, you know, doing things like health, and we need to have some sort of input or agency, like I'm going to do something which is going to cause quote-unquote damage to this bloke over here. Now, in like classic games, like you might launch a projectile or you'll swing your fist or, you know, just some like generic bullshit like that. But in our case, let's just blow apart his brains from the inside out using telekinesis. So if we this is actually another good point. Another way that you can get events is actually just from like key presses and input. So this, I can't believe I overlooked this, but like basically you can have an event for any key on your entire bloody keyboard. And you can look at how to do input mappings and whatever. But what if we say like input face button? Yeah, like gamepad face button and whatever. These are all events because, you know, the player has inputted something which then has the intended effect of like starting an effect in the game, starting a chain of execution. So I can't believe I glossed over that. Input is like one of the most foundational forms of events in game development. But anyway, so for our telekinesis ability, we're just going to say the event is we're going to press 1, and then as soon as we press 1, we're just going to blow this dude's brains out. That's our telekinesis ability. So we've got the event. The next thing that we need to do is how are we going to get a reference to the character that we're destroying? So there is a number of ways that you can do this, and this is where game design comes into things. How are you going to design your game? What are the systems that you're going to use, and what abilities have you got? All of that sort of comes down to how you're going to get your references to things, how your events are going to function, and like that's the meat and potatoes of your game that determines what your game actually is. So, for example, you could use a line trace from the reticle, so you could line up the camera to him and then get a hit result and say whatever we hit with the reticle, that's what we're going to apply damage to. Another way we could do it is you could attach a collision to your character's hand and then have them play a punching montage and then use the overlap event from that hand to then trigger damage events. That's another way that you could do it. And there's endless ways that you can do it. But for the sake of simplicity for this tutorial, we're just going to do something very, very, very basic, which is we're just going to get a direct reference to any blueprint NPC and we're just going to explode them all just with the power of our brain. So we're going to say, how do we get a reference to them all? We're going to say get all actors of class. And then for the input, we're literally just going to say BP NPC. BP NPC. And then basically, so we're inputting a class and then we're getting an array of NPC objects because there could be heaps of them, right? It's like if we're getting all the actors of class, there could be 1,000 of them. So when there's multiple instances of data, you get an array as an output. And then basically what we could do from this is we could say get a copy and say get the first element of the array and then do something to it. So in our case, since we're blowing his brains out, we're just going to say destroy actor. And now in order to emphasize the telekinesis ability, we're going to say spawn emitter at location. And then this is where you could, you know, spawn some like explosions or some shit. I think we get one in here. So we're going to spawn an explosion, and the location that we're going to spawn it at is going to be the location of the first version of the BP NPC. So if we say get location, what was it? Get actor location. Okay, we're getting the location and we're plugging that into there. And then once that is spawned, then we're going to destroy the actor. The reason that we put this before the destroy actor is because if we're using the location of the actor, we can't destroy the actor and then get its location to spawn the emitter because the actor's destroyed. It's gone. It's done. It's dead. It's in the bloody next dimension. So you won't be able to read from that. So now, if we get in the game and press 1, that's our telekinesis ability done, basically. So here we go. We're here. And then one by one, you're dead. You're dead. You're dead. It looks like the first particle effect just glitched out. I don't know why. And if I press it again, it's just going to do nothing and probably give us some errors because this would have returned nothing and then it would have tried to destroy an actor that didn't actually exist. So that's how you can do a basic ability, and this is another way that you can get references to things in the world. So say if there's an actor in your world like a level generator or something, and you don't have an easy way to reference it with like an overlap, what you could do is just say get all actors of class, or you could say get all actors of class with tag, or yeah, no, we'll leave that there. That's sort of interesting. You could say get all actors with interface, or you could say get all actors with tag. And then basically from that, you could just say get copy. And if there's only, say if it's a level generator, you're only going to have one of them in the game. So you can just get the index 0 and that'll just be the one that you want. And then basically you can use that to then cast to your level generator blueprint. And then from your cast to node, then you can say run event, entity gen or level gen or whatever. And then, maybe you could run that off your input key. So whenever you input 1, get the level generator and regenerate the world, for example. That's just, an example of a use case of how to get references to an actor if the actor is sort of abstract and say, isn't in your game mode, because, that's a good way to get it. If you need a node like this, but for something that doesn't come in the engine, like a get node, then basically you just use the get all actors of class and then get the first element, and then you can do whatever the hell you want to it. Now, that's one way to do it. You can also get all actors with interface. So we'll go into interfaces later, but basically if you just create in here, if you go blueprint interface and just call this BPI underscore fundamentals. Sorry if this is a lot to take in, by the way. I feel like you might, depending on your experience with this sort of thing, you might have to watch this video a couple of times, because I'm sort of going here, there, and everywhere. But this is like the foundations of game design, and if you can sort of grasp what's going on here, it's like you sort of just fill in the gaps with whatever else, and you can do anything then. It's like the rest is just sort of trawling through forums to find the right nodes that you need to use and watching tutorials. But these are the basics. So if you give an actor an interface, basically you do that by going to class settings. Maybe we'll do it in our BP NPC area. If you go to class settings and give it an interface, go add, and then what do we call it? BPI fundamentals. Is that? Oh, whoops. Oh, did I just add? Oh, I already added it. Okay, whoops. We can delete that one because we don't need that one. BPI fundamentals. So now, this get all actors with interface now, if you enter BPI fundamentals there, now you've got access to all the NPCs and any other actor that has the interface. And so this array output type now is going to be an array of actors. It's not going to be an array of BP NPC objects, because any actor could have the interface, whereas if the actor class is BP NPC, obviously you're only going to get BP NPCs out the other side of that. But there are cases where this could be useful, like say if you wanted to get all of the enemies in your game, you could give them an enemy interface, and then you could get all the enemies and then destroy all enemies in the entire game with your telekinesis, for example. And the same thing with tags. So if you want to give something a tag, you go class settings, or where is it? Maybe you need to click up here on the left here, say tag, and then you add tags down here. Yeah, and then you can give it a tag, and you can say, I don't know, enemy or NPC, because it's an NPC in this case. And so then what you do is back in here is you just type in NPC there, and now you've got access to anything that has that tag. So that's just another way to get references to things to do stuff to once you fire an event. So I hope that makes sense. And just before we go, if you wanted to apply the effect to all of the actors at once, then what you do is you drag off the array and say for each loop, and then from the loop body you plug that there, and then the array element you plug that into what would normally be plugged into your get node here. So if you control drag that into there, you can delete that. And now basically what this is doing is we're getting all the NPCs, and then for every single NPC, for each NPC, we're going to run this script, which is spawn the emitter and then destroy it. And this is the reference to this specific NPC. So this runs once. We've got 3 NPCs in the world. This runs 3 times. Each of these, that's NPC 1, NPC 2, NPC 3. And then they're all going to run that same thing. And then when it's complete, maybe our character can blow his own brains out to top things off. Oh, that was fucking really dark. Anyway. So if I press 1 now, boom, they all just explode at once. So that's how to do input, and that's how to get references to things in a more abstract way that isn't related to events. And if you wanted to do the line trace method, the reticle method, you can have a look into how to use the line trace by channel. But this involves a little bit of vector math where you're going to be shooting from the eye, shooting forward to whatever distance until you find something, and then basically when you get a hit result, you break that, and then say the hit actor, that's the one that we're going to destroy. And so say now, getting into some more organizational stuff, if you wanted this to be an ability for the character, which is basically detonating an NPC, We can drag this out here with control drag. I'm going to type in reroute node and just plug that into there, and then highlight all of this and then collapse that. And I'm going to call this detonate, or maybe we'll call it ability underscore detonate NPC with telekinesis. And then the input pin, we're just going to rename and call that BP underscore NPC. And now we've just made our first function for the game. This is our first ability, our first character ability. It's the ability to detonate an NPC with telekinesis. That's our first character ability. And so that function operates by taking in the NPC that you want to detonate, and then once you give it that NPC, it just handles the rest. So I'm just going to close some of this down up here. We can do that by pressing the 1 key. Our 1 key is going to be to detonate everything in the game. But say if you just wanted to detonate just one of them, well, what we could do is we could attach that. Let's attach it to the 2 key. Input 2, and we can have the method that we had before, which was get all actors of class. But this time we're just going to get a copy. And then we're just going to copy this detonate node over here. And we're just going to detonate whichever one it just happens to get first. And so now we've got 2 character abilities, or 1 character ability, but used in 2 different ways. So if I press 2, it's going to just destroy them one at a time. And if I press 1, it's using the same function, but it destroys them all together. So that's a good... Using functions like this is for your abilities or wherever you're reusing something. This is the beginning of an ability system, basically. We're already sort of getting to the point where we're making character abilities, and then this is just a clever way of doing the references. And if you wanted to do it with a reticle trace, basically what you would do is you would drag off the hit actor, and then you would just say, what was it? Detonate. Oh, we can't detonate it, and you want to know why? Because this pin here, this is something to keep in mind if you're ever looking for a node and it's not showing up for whatever reason. If you look at the hit actor, it's of actor object reference. So this could be any actor. It doesn't have to be the NPC. Whereas this, we've told this to specifically work with the blueprint NPC object. Now, that doesn't have to be the case. It should be able to work with any object, unless our ability is specifically the ability to just detonate NPCs. Like it could be that, if you wanted to be like discriminatory against BP NPCs, like that could be a whole part of the plot of your game. And if that was the case, then basically the way that you would set up your line trace is, say if you inputted 3 to execute a line trace, and then assuming that all of this data was correct, and then hit the actor that was under your reticle, basically what you would do to make it discriminatory for BP NPCs is you would say cast to BP NPC, because you only want it to work for BP NPCs. That's the way that the cast node works, is you're separating out, you're having an input of what could potentially be any actor in the entire thing, your entire project, and you're saying we only want this to work for blueprint NPCs and everything else is just going to fail. So then what you could do is you could say detonate with telekinesis, okay? But this typically is bad game design, because now you've created a dependency where what would otherwise be an ability that could be applied to anything, you've reduced it to just being applied to blueprint NPCs, which is sort of unnecessary. So if we break both of these pins, and if I break this one over here and just delete that for a minute, and we open this up, we're going to break this as well. Now this is type actor object reference, okay? So the reason that this is type actor is because destroy actor, that doesn't need to be specific to BP NPC. Get actor location, that doesn't need to be specific to BP NPC. And so this pin can just be an actor pin. It doesn't have to be a BP NPC. So if we delete this, take a shot for every time I say BP NPC, by the way. If we change this to actor, like that, and we just change this to actor, so type actor, name actor, or we could call this actor to detonate to just be more specific, and plug that in there. Now, this is still going to work fine because BP NPC is type actor, so they're fine. But now also down here is anything that we hit with the reticle, we can now detonate it. So we haven't actually set the reticle up, but you know, just hypothetically, that's like how you do it. Maybe what we could do is just for a bit of fun. Actually, this is actually another good point to illustrate. So I showed you how to do getting all actors of class, but maybe for a third example down here. So just for a third example is another way to get references to objects. What if let's say our character's telekinesis ability was only applicable in a certain range? So what we could do is we could add a sphere collision, just like we did earlier. Let's say the range is 512 units. It's quite big, or maybe we'll go a little bit smaller. We'll go 256. We'll go 256. Whenever you input the ability through, well, one thing that we could do already is we could just say on overlap, just automatically telekinesis the brains out of whoever we touch. That's one way to do it. If you've got a character with like just a bloodthirsty aura that just obliterates everything in its path, that could be a game mechanic potentially if you wanted to go that route. But let's say you want the character to be able to activate it on demand. It's like they can have a thought and then just detonate everything that's around them. What you would do is on the input 3, we're going to get a reference to our sphere. So we got the event, input 3, we need a reference sphere, and we're going to say get overlapping actors. So this is a good way to get references to things to destroy. And then for the class filter, well, do we want to filter it for BP NPCs or do we just want it to be everything? Let's just make it everything, right? Why the hell not? So we'll make it class actor, and then we're going to use our normal for each loop. And then for each actor that is overlapped by our sphere collision, we're just going to detonate it. So I wonder if that'll work for the floor. What do you think? The floor is a static mesh actor. You can see up there, so it's not actually an actor. So is this over here. So they're not going to be destroyed because they're like level geometry. But the cube, let's see if we can get our cubes in. The cubes, they should be destroyed because they're of type actor. So let's see how that goes. Now I don't know how wide my volume is because I haven't tested it. But if I press 3 over here, oh, I killed myself. Isn't that hilarious? Yeah. This is to be honest, shit like that, like it's sort of in my brain that begs the question of like bug versus feature. It's like obviously you don't want to just have your character to be able to kill themselves like that because it sort of like ruins the game, but like there is a way to like tastefully make that part of the game where it's like, well, okay, say your character is executing a telekinesis ability, they're casting a spell to destroy all sentient life forms around them. If they as a player forget to input, you know, a protection spell on themselves, for example, then their detonation spell is just indiscriminatory and it's going to just destroy everything. I think that's cool, right? Like that's systemic game design where the rules apply to everyone and the player isn't a specific like case. I think those are the best kinds of games. It's like the games where you feel like you're in a world where it's just indifferent, the rules are the rules, and you're not like at like a theme park where it's like everything is like just for you. Those games are fucking boring, man, where it's like everything is on rails and you can't just make shit go out of control. So this is how you make systemic game designs. You leave stuff like that in, but then obviously give the player the tools for like casting a protection spell or whatever to protect themselves from their own detonating actors. So just on that note, let's go ability detonate actor is what that is now with telekinesis, because it's a telekinesis ability. It's not just a destroy actor ability, it's a telekinesis ability. And if you remind yourself of that, then that helps you think about how you're going to do the feedback and, you know, make the game actually feel real rather than just things blipping in and out of existence on the screen. And so when you input 3, let us, well, we could do this the boring way. The boring way is to say, well, for each actor we overlap, we're going to say is equal to the player character, and then B and left click for a branch. If it's equal to the player character, then don't do it, and then just detonate the actor. That's the boring way to do it. But let's say we wanted to do it following the game design, the emergent game design principles and systemic game design is, well, one way that we could do it is we could say, let's say when you press 3, you automatically cast a protection spell on yourself, which then prevents you from being damaged by telekinesis. So what we would do is we would say add gameplay tag. I wonder if I could do that. How do I just add a normal tag? I don't want to do a gameplay tag. I want to just I think I have to go get tags. If I say get tags, so this is the tags for the actor, and we say add an element to that array, and we're going to call this immune to telekinesis. So this is the protection spell. I've just cast a protection spell on myself. I'm immune to telekinesis now, but the functionality isn't in the game yet. So what we're going to do here and say we're going to say actor has tag, and did I copy that? I don't remember. No, I didn't. We're going to copy that tag there and just put that in here. We should do this as a variable, but I'm just going to copy and paste for now, just for demonstration. If they have the immune to telekinesis tag, we're not going to do anything because they're immune, right? So boom, just like that. And now when the loop ends, we're going to remove item, immune to telekinesis down there, just like that. So this is a more, I want to say, just intelligent way of doing your game design. Rather than making special cases for the character, which is what we had before with the is equal to player character node, dog shit. This is creating a new ability where you can add a tag to the character, which then makes them immune. So, like, for example, we could use the timer logic that we created earlier, and maybe we could give them like an input for key where they can add that tag, and then we could say set timer by event, and then give them 3 seconds or whatever, and then create an event over here which is then remove. Oh my god, I'm like creating this as fast as I was just gonna bloody explain the thing. If we just create an event, create a matching function, we could just call this end telekinesis immunity, and we could just put that in there, right? And now you've got a protection spell that lasts for 3 seconds. Like, obviously, like this is just the basics, and you want to do feedback, you want to do particle effects and sounds and shit to actually communicate to the player what's happening, because nothing's going to show up on the screen at this point except for the fact that I'm going to go to detonate shit and I'm just not going to die. But that's a protection spell, and this is a telekinesis spell to destroy everything around me except for anything that is immune. So if I go in now and press 3, we've got auto immunity built into this spell. So if I might press it over here first. 3. Okay, it looks like it destroyed the BP events blueprint, and it's destroyed that one there too now. So if I press 3, it destroyed all of them except for the middle one. That's interesting. And then I pressed it again, and that time it worked. I wonder what the deal was with that. Oh, it's only getting 2 of them at a time. That's very interesting. It seems like it might be limited somehow, or somehow they might have got the tag. I wonder if that's seems to be a bug. Very interesting. I wonder if the overlap event is like failing somehow. It's only handling 2 at a time. Huh. Anyway, so I just did a little test, and if I put the print string in here, I'm just gonna do some debugging just so that you can sort of see how I go about doing these things. If I put a print string there just to see which actors are getting picked up by the overlap actor thing. If I press 3, okay, got all 3 of them that time, so that was unexpected. But if I do it here, it only picked up 2 of them. So we've got NPC and NPC2. So sometimes it gets them all, other times it seems to miss one. And I am going to predict that maybe the reason for that is because this is a green node, which means it's a pure node. Whereas before we didn't have that problem over here where we were using this blue one, which is an impure node. So the difference between those two is this one requires an execution pin, whereas this one doesn't. And my suspicion is that what's actually happening is when they're impure, they run only once, and then this output, this remains the same for anything that calls on that. So this is calling from this 3 times because it's executing 3 times for each of those different blueprint NPCs. But it's using the same output of this. Whereas this one over here, I think this pure function, every time this is running, I think it could be potentially getting the actors in a different order and then fucking up the index or something. So what I'm just going to do is I'm just going to promote this to a variable. I'm just going to do this dirty for now. And just call that overlapping actors and just see if this solves the problem. And then plug that into there. So that this only occurs once. And then this is set because it's in the execution chain. And then that's going to run impurely and not purely. Let's just see if that solves the problem. Okay, that worked better. It got 2 out of 3 of these ones because I increased the radius of my trigger over here. If I reduce that back to 256. So let's try that again. If I do it over here and press 3, nothing. If I do it over here, yeah, we get both of those. Now if I stand up close to these, we get all 3 of those, and then we get all 3 of those, yeah. So that's just a little tidbit and something to be careful about with these impure ones. Whenever you have a get node that is green, just be aware that this could be being called multiple times, and when you're getting overlapping actors, they might not necessarily be in the same order every time as well. So I think that was fucking up with the array somehow. So that's just something to be aware of. And now, if I were going to tidy this up to be an ability, because I said this was messy, what I'm going to do is I'm going to delete that because I don't need this variable inside of here like that because it's just a temporary variable. I'm going to hook that back up. I'm going to hook that back up for now. This as an ability is casting a protection spell. So we could even like just call that like enable telekinesis immunity. And then we can get rid of this over here and just replace that like that. Rather than having the same code copy and pasted in different places, you want to use the same function so that then you can edit it all in the one place and have it updated everywhere automatically. That's just good practice. And then we have our end telekinesis ability on a timer over here. Now, in this case over here, for the sake of our ability, we're enabling telekinesis immunity, and then we're detonating everything that's in our radius. Let's collapse that to a function. Let's call this ability underscore detonate all surrounding characters. Right? And notice that I said characters, not enemies, because we have deliberately left that non-specific to enemies. It does include the character. It includes the player character itself. And then, of course, over here we've got this remove one, which we can then replace that with end telekinesis immunity. Now we're going to have to be careful here because if this is sort of getting into more detailed stuff now, which is the complexity of game design, which you'll learn about the more you do it, is that if we cast a protection spell and then cast this one here, this is going to cancel the protection spell. So, you know, if you were going to make this into an actual game, you'd need to invent some clever way for these abilities to communicate with each other so that shit like that doesn't happen. But anyway, this is like an ability system framework now. We've got an ability here, which is a protection spell. This is like a concatenation. It's like a chain. It's like a chain of different spells all together in one. It's a chain of abilities all together in one to produce one sort of mega ability. This is how I like to do abilities. I like to break them down into smaller parts which can be concatenated and then combined in different ways to produce insane shit that happens on an input. And then this is like another one over there. So if we just jump in now and just test, and I press 3, fine, I'm not dying, that's good. And then I press it there. Oh, I wonder if that actually worked that time. Oh, it looks like we have the same issue. Oh, that's funny because when I did this, I put it back to the way that it was rather than the fixed version. So the reason that I put this into a function is because we're going to promote that to a local variable now and call that LV underscore overlapped characters or overlapped actors. It's overlapped actors, really. I should call it overlap actors. And we're just going to plug that in just like that. It's cool that they've got that little sigil up there that never used to be there. So now, if we jump in, you can see that it's working correctly again. And it's, you know, it's going to work for any actor in the entire game. The ones on the map geometry are static mesh actors, so we're not going to destroy those. Although, if you wanted to destroy them, the way that you would do that is you could just include static mesh actors in here. So if I just change that like that, I wonder if that'll just work out the box. What did I do? I just pressed 3. Maybe because they don't have an overlap on them, it doesn't actually work. Oh well, anyway, it was a nice idea. So there you go, that's some stuff on abilities. Now, I'm just going to do a couple more things before I wrap this up today because I'm sort of getting to my limit with how much I can teach at the moment. The reason that we got into doing those abilities was to explore this instigated any damage node, and I think we might do a more detailed damage system in a different video, but just to explain sort of what this does is inside of our character abilities here that we made. We had this ability to detonate surrounding characters. And we had this one here, which was detonating a specific actor with telekinesis, where we just simply destroyed the actor. Rather than destroying the actor, we could say damage. What is it? Apply damage. So we've got this event here where we can apply damage to the damage actor, which is the actor to detonate in this case. And then the base damage, let's say it's like 100, you're giving them 100 damage. Okay. And the damage, the event instigator is an object controller. So this is the controller that's responsible for the damage. Now, in our case, because this is the third person character, it's always just going to be the player controller. So we're just going to put that in. We're just going to do it dirty for now. And then basically this is an interface event. So if we were to go into the blueprint NPC now and we say event any damage, this is the event that's going to fire when this actor takes damage. Now, what we could do is say if the damage is, let's just say, for now, if it's equal to or greater than 100, ideally you'd want to give them like a health system where they have a value of how much health they've got, and then you subtract the damage or whatever. But just for simple, if it's greater than 100, we're just going to say destroy actor, and it's basically, it's the same system as before. So if we go into our third person character now, we don't actually need this destroy actor node now because we're dealing damage to them. And why don't we let's just see if that works. It's not going to work for our blocks because they haven't got the interface in them right now. But if we press 3, you can see, yeah, they're getting destroyed. I wonder if they all didn't get destroyed at once because I was too far. Yeah, so you see that works. Now these ones are still exploding and they're getting damaged, quote unquote, because they're also receiving, they're spawning the emitter at the location and they're being applied damage to, but they're not being destroyed because the destroyed thing is only inside of the BP NPC. Now, in a separate video, when I've got a bit more brain power, I'll show you that you can put this in a place like an actor component, for example, or in a parent class where the damage system can apply to the NPC. It can apply to you as a player character, because at the moment I'm immune to it as well, because the only thing that can be destroyed is the BP NPC, and it's also the events are immune to it. Everything is immune for it basically, except for the place where we've implemented it, and that's just bad practice because you want the rules to be the same everywhere. And so what you'd want to do is you'd want to put the health system in something generic that can be applied to characters. It can be applied to an actor. It can be applied to maybe even the level geometry if you wanted to go that route. Like who the fuck knows? That's game design decisions. But you know, just for this demonstration, this is how you use the damage event as an interface. It's an easy way to say we're applying damage. Okay, the damage actor can be anybody, and then basically whenever this node is called, it's going to call that event inside of the target actor's blueprint, the damaged actor's blueprint, to do whatever they want with. Now, this is relevant to the player controller, which I think I closed down, because we have this event here, which is saying event receive instigated any damage. So when this controller instigates any damage, we're going to print the damage up in the top right of the screen. So let's see if that actually works. I wasn't actually paying attention before. It didn't actually work, did it? So we're definitely instigating the damage, but for some reason it's not coming through. And as soon as I stop that recording, I think I might know the reason why it didn't come through, because what happened to our PC? It's just there. This isn't actually being implemented yet. We need to go to our game mode, which is our GMB fundamentals, and we need to add in our player controller fundamentals, because otherwise it was just using the default player controller. And the way that we can tell if it's using the correct player controller is we could just use the begin play node and say print string, hi, I'm using the PC fundamentals. Or even a better way to do it is you could just say get a reference to self. This is another good way to get references, is you can just say self, and then that just refers to this object. So you can just plug that in there, and if we get that message, then we know that we're using the correct controller, which we are not, it seems. So I wonder why that is. I wonder if it's because we're not even implementing the game mode, because down here we've got a game mode override and it's using the third person game mode. So let's reset that to default, and then will that work now? Let's see. Did we actually set it up? No, we still didn't get the message. And because the other thing that we need to do is we need to go to project settings, maps and modes, and default game mode is the third person game mode. So that's our problem. We want that to be GMB fundamentals, which is our custom game mode that we made before. So now if we press play, couldn't spawn player, could not find starting spot. That's interesting, probably because we overrode the find player start. Remember, we were playing with these functions to see what we could override. So we just like glitched out our own game mode, and the game actually couldn't start. So now what happens? Now we don't get anything. That's interesting. So in GMB, well, we get a spectator pawn. If we go to the default and then go to our default pawn class, of course, we need to add in our BP third person character. So now let's see. Okay, that still didn't want to work. I wonder if that's got something to do with these events. I reckon because I've added that in, I reckon that might have overridden something significant. I'm not actually sure how all of these work, so it's probably not a good idea to just keep them there for no reason. But you can see that we're in now, so that's like basically working. And did we get the player controller message? Yeah, see, we got the player controller up there. So if I press 3 now, nothing's happening. We don't get any damage. But if I go over here, you can see we got a bunch of 100s there. So we're inflicting a bunch of damage because we're using this apply damage node and we're giving it an event instigator, and then that is then communicating with our player controller, and this event is firing whenever this player controller instigates any damage. And we can also read the damaged actor as well. So if we wanted to like have a message box on our game that tells you when you killed a player or damaged a player, this is how you'd do it. You'd say, well, whenever we instigate any damage, get the damaged actor and then like print their name to the screen or print their name to the HUD. So let's jump in now. And if we press 3, you can see we get physics, objects, and NPC. Yeah, just like that. So you can see who we're damaging. So that is one example of the events that you could use in the player controller. You could also create and destroy the HUD whenever they possess or unpossess a pawn, for example. Like say you want to display a different stamina bar when you possess like say you're going to ride an animal or drive a car or something. You would take the possessed pawn, and then you could maybe like get the class and then say, is there like a switch on class node? Or maybe we could say, you could say equal to, and then if it's equal to such and such, then display this HUD. Or probably a better way to do it would be, how would you do it? You'd say find in an array, and then you'd have an array of different classes with different HUDs. And then you would say switch on integer, and then basically whatever selection you end up getting, then you could say make this HUD or make this HUD or make this HUD or whatever. And then when you unpossess, then you can return to the default HUD. So, you know, that's some stuff that you can do inside the player controller. The player controller is a good place to handle HUDs, I think. But you know, through experience and playing around with the different types of assets, you could do HUDs in whatever blueprint you want. You can do anything in whatever blueprint you want, and you'll quickly come to learn the limitations of doing things a certain way, and then you'll be able to move stuff to where it should be and redo your systems and whatever. So don't worry too much about it. I think the best way to learn is just sort of through trial and error and seeing what works and seeing what doesn't, and being creative and following the things that are interesting to you. So the very last thing that we haven't looked at, and which will probably be the last sort of topic today, we've covered a lot to do with blueprints and a lot to do with different event types and a lot to do with different classes of actor. But there's one type that we haven't looked at yet, which I probably think is one of the most important and might even deserve its own video later on, is these two down here. So actor component and the scene component. The actor component, so this is similar to, well, you can read it. It's a reusable component that can be added to any actor. Just before we even explore custom actor components, let's just go up to our viewport over here, or maybe we will do this in, we might even do it in a new blueprint. Let's go to actors. We're going to create a new blueprint, and we're just going to call this BP underscore component demo. And we'll give it a static mesh. So this is an actor component already. A static mesh is an actor component. Anything that's added up in here is an actor component. There's all different types. So this is a static mesh component, obviously. Let's give it a Can we give it like a triangular or pyramid or something is what it's called? A quad pyramid. Let's go to the quad pyramid. That looks kind of cool. So it's got a static mesh. Now, adding components, there's a bunch of different shit that you can add in here. This is going to be its whole other video. So you can explore through these and see what there is in here, but there's a whole bunch of functionality just already inside of Unreal Engine that you can fuck around with in terms of actor components. But a few of the good ones, so common, I don't know what that one is. Heterogeneous volume, interesting. Anyway, audio is a good one. So if you want something to play sounds and emit sounds, you can just add the sound as a component. Lights are good. We'll get to sync components. Skeletal mesh, that's something you can animate. A static mesh is something that is static. You can't animate it like a cube. These are just basic shapes down there. AI stuff is very interesting. So you can obviously give it behavior trees, blackboards, pawn sensing. I've got tutorials on AI online. I've got a YouTube tutorial series called AI Made Easy, which goes through blackboards and behavior trees and stuff. It's an old video, but it's still relevant. Like all the fundamentals are still relevant. So if you want to get into behavior trees, you can look at that there. And there are a couple of cool ones like sort of done it. Well, there's heaps of shit here. Like I don't even know how to use all these, but you know you can look into them. Lights are good to know. Movement's interesting. So floating pawn component is a good one for like spectator pawns. Interp to component. So say you wanted to move your pyramid from left to right, or have a door that's slid up, open and closed, or something like that. You can do that with the interp movement component. That's a very good one. The rotating movement is a classic, which I'm just going to add onto here. So this is just going to make it rotate. You know, so that's just actor components, man. Those are the ones that come as default in the engine, but the real strength of actor components is in the ones that you make yourself. So I'm going to create a new folder and call this components. And then I'm going to right click and then go blueprint class and go actor component and just call this AC underscore, why don't we just call it demo component? We'll just go through a bunch of just sort of generic shit. So inside of this, you can see that we've got begin play and we've got event tick, same normal stuff. What have we got in here? We've got an end play and we've got an async physics task. Like I don't even know what that is. I'm not even going to worry about that, but end play could be interesting. Same as the actor component. But the real strength of actor components, I think, is sort of in, this is where we sort of get into our own custom events and event dispatcher territory. So this is sort of the last topic to perhaps cover when we're talking about events. An event dispatcher, why don't we just create one and I'll tell you. Event dispatcher, why don't we call this just my event dispatcher, and I'll show you what it does. So basically, this thing here, if I drag this in, I get a bunch of different options. The main one that I use is just call. And when this is called, basically it's going to dispatch a bunch of different events in other places. That's sort of like calling an event, but it's like calling a custom event, but a little bit more versatile. It's going to call any event that is bound to this event dispatcher. So to show you what that means, if I go into our component demo up here, and if we add our AC underscore demo component, we can just drop that in there. You know how earlier I was showing you how you can add events and things like that. If we click on this here, you can see down here we've got my event dispatcher. So this is a way for you to create your own events, which then you can like bind stuff to inside of here. So if I click that, we've now got this in here, and maybe already you're starting to see like the potential of this. This is like where events just start to get interwoven with events, and the game becomes a big web of like interconnected shit communicating with each other. And I think this is where the complexity and the beauty of emergent and systemic game design like really comes to the forefront. So anyway, so let's just say that on begin play, we're just going to call that event dispatcher, and inside of our little pyramid here, whenever that is called, maybe we can just like destroy the rotating movement component, like just to show that it's working, you know. So if we go ahead and just drop that in there, we somehow got two of them. My computer seems to be like freaking out a little bit, but if I jump in and play, you can see that they're not rotating because the event dispatcher was called. So if I disconnect that like that, you can see that they're rotating. So very basic example. Now, a use case where this might be a little bit more interesting. Well, let me just say a couple of ways that you could do this. For example, if this actor component, this can basically be, it can be anything. Like this could be anything that you can add to a actor or add to a character. So say this instead was like a storage box. Like this component demo was like a treasure chest in like Minecraft or something. One property of a treasure chest is the fact that it can have an inventory. So maybe this inventory component could be added to the chest. The inventory component could be added to the player characters. The inventory component could be added to an enemy. And then basically it's like you've got the same component that is used among different actors. So say if you interact with the chest, it opens the inventory component. If you kill an enemy, it empties the inventory component onto the ground. And if the player dies, then, you know, the same thing, it empties them onto the ground, or maybe they're saved, or goes to their friend, or like, you know, just whatever. But basically the real strength of actor components is that they can be reused across different actor classes to provide basically the same functionality. I think inventory component's a good example. But then, so say this was an inventory component, and let's just think about, well, what sort of, I'm not gonna build an inventory component right now because that'll probably take a little bit of time, but let's just think about what are the kind of ways that you would interact with an inventory component. Is one way that you can interact with a component, let's just add a function like an API, is add item to inventory, for example. Another one would be remove item from inventory. And another one would be drop all items in inventory. So this is just sort of, I'm just going to do this meta and not actually write all the scripts, but just sort of give you an overview. So if we look at the add item to inventory function, we might have an input, which is basically just the item ID, okay? Just basic. And then remove item from inventory. Is that actually, yeah, that's working. You know, which item are we moving? We'll just give that also an item ID. That's just going to tell us which item that we're removing. And then if we're dropping all items in inventory, the way that we would do that, drop all items in inventory. Where am I? Delete that. If we're going to drop all the items from inventories, basically we would have a for loop, which went through basically every item in the game. So maybe there's like, I don't know, 16 different types of items or whatever. And then you're just going to remove each one of those items from the inventory and like drop them on the ground. So that's just like an idea of like an API for how you would do an inventory. And maybe we'll do an inventory in a later video, or you could watch tutorials for that on YouTube because there's plenty of them. There's so many different inventory tutorials. But as this relates to event dispatches, is maybe you want to tell the player whenever they've updated the inventory. So we could add an event dispatcher which is called inventory updated, and we can call that whenever we add something or whenever we remove something. And this is helpful because say we had a HUD that was going to display the inventory, we could then use this event dispatcher here to refresh the items displayed in the inventory whenever something is changed. So for example, inside of our component demo here, what if we go to our demo component? I'm just going to go Control B to go to the demo component and just call this demo inventory. We're gonna just make it an inventory, okay? So say this component demo blueprint is actually going to be renamed as BP chest demo, and I might just reset the static mesh to a cube. So basically this is a chest now, okay? It's not a spinning pyramid, it's a chest, and it's got a, I'm going to delete that demo component for a second, and I'm just going to re-add it, AC inventory component, because we changed the name of it and it still had the old name, so I'm just going to add the new name. And so now this is a chest, okay, metaphorically, and it's got an inventory inside it. So it basically contains a bunch of items, and the way that you would tell it which items it had is you would go into variables and you would create an array, and this would be inventory list. And basically, you know, this would be a collection of I'm just going to recompile it. you know, that's, you got, I don't know, 4 of item 1 and 8 of item 2, like whatever. And so if you go to the chest demo, again, I'll do all this in detail another time, but you can read on here what's inside the inventory just there. And now say if this chest demo had a HUD, what you could basically do is just grab this component here, and you could do this add event thing here, my event dispatcher. Sorry, not my event dispatcher. We want to use inventory updated. Is whenever the inventory is updated using these functions, because they're calling the event dispatcher, is that then now we can use this and then go and update. We could create a function which is like refresh HUD, for example. So that's one way of doing event dispatchers. I just wanted to introduce you to that concept because it's a very powerful way to leverage custom events inside of actor components, which are then going to be used across different actors. And you can really do a lot with this. But just one more thing that I'm gonna show you about event dispatchers before we pack up is just what it means to bind to an event dispatcher. So say we had our blueprint NPC guy over here, and let's say he was running around and he's like a scheming little money hungry merchant who wants to know what is inside of everybody's inventory at all times. Basically, what we could do for him is we could give him we'll give him a sphere collision, or maybe let's not even give him a sphere collision. Let's just say he's a god-brained, like sentient NPC that just knows what everybody's holding in their bag. He can just see it in your eyes or see it into your soul. So let's just say on event begin play, we could start a function. I'm just going to be really sloppy right now and just chuck a delay in. Every second, basically, what he's going to do is he's going to get all actors with, maybe let's say, well, which one are we going to do? Let's say all actors with interface. Or maybe let's just say all actors of class. We're going to say get all actors of class. He's going to get all characters in the game. Oh, well, he's actually, no, we can't do that. We're going to just say, what if we just say all actors? This is going to be pretty messy. It's going to be really messy, unfortunately, but I'm sort of running out of steam. He's going to just scan everything in the entire game. Maybe we don't even need that delay, actually. We could probably just do that like this. And we're going to say get component by class. We're going to get we're going to see if they've got an inventory component. So what we need to do is we need to say is valid. Okay, so we're scanning every actor in the entire game. We're going to check if they've got an inventory component. And if they do have an inventory component, then we're going to say bind event to inventory updated. Okay, so this is what we call like listening. Basically, we're saying that as soon as the game begins, this guy, BP NPC, he is going to listen for every single inventory component in the game, and he's going to be notified of any updates that occur. So what we can do is we can do our usual thing, which is create event, create matching function, and we're going to just call this somebody updated their inventory. So this is going to fire every single time, just as an example. And so he knows. So he's just going to say print string, and he's just going to say to the world, it's going to be like, I see that you have changed something in that bag of yours, sir. And he's going to spit that every time somebody changes their inventory. So now we don't actually have a method for changing the inventory, but what if we give our character an inventory? So if we say AC demo inventory, now our character has an inventory, and whenever we press input button 5, we're going to get that inventory component, get a reference to the inventory component, got the event, get the reference, now do the action. We're going to say add item to inventory. Basically, we're just going to pocket item ID 0, which let's just say in our world 0 is like for a stone on the ground. Basically, every time I press 5, our character is going to pick up a stone from the ground and is going to add it to his inventory. And it doesn't have the functionality in there yet. Like what you would do is you'd say increment item ID by 1 or whatever to add add the stone to the inventory, and then you'd obviously want your feedback, you'd want your effects, you'd want him to like kneel down and like pick up a stone or like whatever. But just for sort of the big picture thing, 5 is to pick up a stone from the ground. Okay, so now if we go in the game and let's just delete these, we only want one of them. So this is our little penny pincher merchant man who's paying attention to how much money everybody's got. So if we jump in the game and I press 5, I see that you've changed something in your bag. Blah 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 blah. So he's listening, bro, and it's like it's not running on tick, it's not running on a timer, it's running on events. So it's like the most performant way that you can do it. And every time my inventory change, he knows about it, and he can turn to face me. He could like, so for example, like if somebody updated their inventory, a good question to ask actually would be, well, who updated their inventory? Why don't we do that, and then we can make him look at you. So a little bit freaky, but let's just say, so to do that, if we go to our inventory here, inventory is updated. We need to add an input to this. So if we click on that down there, add an input, it's going to be of type actor. And this is going to be owner of inventory component. Okay, and then if I hit F7 to refresh, that's going to break everything because these don't update that easily. If I go up to here and I say refresh all nodes, that seems to have worked. So now, whenever we add an item to an inventory, we're going to just say get owner. Okay, so this blueprint that we're working in is AC demo inventory. This is the inventory component, and the owner of the component is it's either going to be our third person character, it's going to be the BP NPC, it could be anybody. It could be anybody with the inventory. But basically, whenever we add something to the inventory, we're going to say, hey, we're the owner to anybody who is listening for that change. I hope that makes sense. If it doesn't, like, don't worry about it. Like, you'll wrap your head around it eventually. And so we're going to do the same thing when we remove an item from the inventory. And now let's say inside of our blueprint NPC, somebody updated their inventory. I wonder if we refresh this, we'll get an error because we changed what's called the signature of this function. So basically this function that we created, this doesn't work anymore because it's got a new input on it. So if we delete that now, this is going to not be happy. Can I refresh this? It can't find the function because we deleted it. So if we now say create a new matching function, you can see that we've got this pin here. So now if we say set actor rotation, sorry, I did that technically the wrong way. Oh no, I didn't. It's just referring to the self. But usually you want to say get a reference to the self because you need a reference before you try to do something. And then you're going to say get actor rotation. I want to try and, not get actor rotation, but set actor rotation. I want to try and teach this in like the most logical way so that everything is demystified. Now the new rotation, there's a little cheeky node that you can hear, which you can use here, which is going to be called find look at rotation. And I'm just going to do some vector math here. The start of the look at rotation is going to be get actor location. It's going to be our location of the NPC, and the target is going to be the owner of the inventory component. So we're going to say get actor, not tick interval. I might just be able to copy that one there, plug that into there. I'll tell you what, I'm so excited for the day that Neuralink comes out and I can just look at this blueprint and say I want to connect that pin to there and this pin to here, and I don't have to use my mouse and type. I am like so keen for how blueprints are going to speed up when I've got a fucking dystopian cyborg chip in my brain. Anyway, we're just going to split these two pins here because we don't want the roll or the pitch, we just want the yaw. And so now let's just rename this function because it is, what was it called? Somebody updated their inventory is what we called it. And this is inside of our blueprint NPC penny pincher. And so now if I come over here now, and I'm right behind him, so I hide behind here, and let's say I pick up a rock over in the corner. I think it was key number 5. See that, bro? He just fucking looks straight at me. He's like, your inventory changed. What did you put in your pocket? Why are you not sharing it? Give me all your money. There you go. So here's our little penny pincher NPC. Alright, so I hope that explains a little bit about actor components and event dispatches. But basically, the last thing that I will say, I've already said that so many times, but we're BP NPC. So on begin play, we began listening for every inventory in the game, and he's listening for when anybody changes their inventory. So even if it wasn't the character, it could be an AI that picks something up. He's going to know about it. He's going to look straight at them. Now, say you clapped him over the head with like a cricket bat or something, and he no longer has the ability to read people's mind and know when they've put money in their pocket, and you wanted to take his ability away. Basically what you do is, we could do it on completed here. We could have a delay and say after 10 seconds, hypothetically, somebody claps him in the back of the head. We are going to do this same thing. We're going to... Oh, well, how would we actually do this? Well, actually, what we could do is we could... Oh, how the fuck am I going to do it? I'm not actually going to do it. What I'm going to do is just tell you what you can do, and it'll make sense. Basically, you want to do this whole thing again, except instead of bind event to inventory component, you're just going to say unbind all events from inventory updated. So basically, you'd run this whole script again, except instead of listening for whenever anybody in the game changes their inventory, you'd say unbind all events from inventory updated, and now he is no longer listening for anyone. So that's how you do bind and unbind, and sort of a use case for them. So you're giving someone the ability to listen, or you're taking away their ability to listen. So there's all different kinds of ways you can use that. You're limited by your imagination, really, but we'll do more examples later. Alright guys, so that's it for the first tutorial video in this series. That felt like quite a long one. I feel a bit like flushed in the cheeks and a little bit, like my brain is a little bit on fire. But I hope that gave you a good sort of introduction and an overview to events, how events work, sort of the foundational concepts of Unreal Engine, how the different Blueprint components work, how to use event dispatchers, how to use the different classes like your player controller and your game state, and hopefully introduced you to a couple of nodes and whatever. And I hope that drawing at the start as well sort of helped explain, you know, how all of this works, and also the examples as well. But thanks for watching this far. If you've made it this far, I'd love to hear from you. I'd love to hear your feedback on this content. Like, was it hard to follow? Was it helpful? Which examples did you like? What would you like to see more of? Was there something that you feel like I missed in this one that you'd like to see in the next one? It'd be good to hear what kind of videos you would like to see coming up as well. Like I said, I'm going to do a lot more of these and I'm going to explore as many different corners of the engine as I can. So it'd be good to get your feedback to see what sort of stuff you'd like me to cover, so that I can really do my best to make it as complete, I guess, as possible. Before you go, if you are interested in learning more, you can book a call with me where I can tutor you through blueprints and help you wrap your head around some of the stuff that is in here. So there'll be a link to that in the description. You can also, if you're interested in taking a course to help you actually complete an indie game, so you can check out the Indie Dev Intensive. There'll be a link to that in the description as well. In that, I don't do any blueprints like this, but what I do is I help you do the game design stuff. So as you would have heard in this video, I riffed on a bunch of different sort of game design principles, and then I'd show you how you do it in blueprints, like things like the systemic game design and how to do emergence and things like that. Basically, actually completing an indie game and coming up with the idea, translating that to blueprints, staying on schedule, making sure you've got backups, making sure that your project isn't spiraling out of control and that you're not consumed by self-doubt and lack of motivation and shit like that. All of that sort of falls under the soft skills of basically indie game development. And so the Indie Game Dev Intensive, the Indie Dev Intensive, is a 12-week course that works you through all those stages of planning and building and designing and ultimately finishing and then uploading your project to Steam. All the stuff that isn't covered here and just the purely technical blueprint stuff. So if you want to check out that, there's a link to that in the description. And the project files for this will be available as well. So I think that's everything. I hope you enjoyed it. Please do the usual stuff like and subscribe and blah, 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 blah. It really helps the channel. The support, algorithm, comments help as well. If this content you think would help somebody that you know, I'd really appreciate it if you would just send it over to them too. I want to help as many people as possible become proficient game devs. I think it's better for all of us involved. And if you come over and join the Discord community as well, we can help troubleshoot different problems that you've got. We can all sort of work together like that. And I don't know if this will be up by the time I publish this video, but I'm starting a apprenticeship program as well, where you can work on a project of mine or a project of your own and sort of have regular meetings with me and other people in the Discord server to sort of give our feedback and just give guidance on what you're doing and maybe what to think about next, and different ways that you might want to go about doing your blueprints and things like that, so that you can gain some experience actually sort of, building a project out, and not just being alone. Like, I feel like if you're just doing something alone, it's still a great way to learn. That's how I learned. Like, I just fucked around in blueprints and learned from trial and error for just years and years and years and years, and just trawling through forums and watching tutorials and things. But I think you can learn a lot faster if you have a mentor. And I didn't have a mentor, unfortunately, but I am available to mentor you, either one-on-one if you want to go that route, or you can come and work with me on one of my projects, and I can mentor you and help you build out the systems there, because that would do me a massive favor, because I'm only one guy and I can only do so much blueprint work. And if you want, you can come and jump on one of those projects, and I can help you see the way that I work and how I plan my projects, and you can learn sort of through osmosis. So that's the slightly esoteric apprenticeship program. There's going to be a link to that in the description as well, where you can check out the projects that are in that. So that's it for now. Thanks for watching, and I'll see you in the next one. Bye.